So, ladies and gentlemen, good morning and welcome back for the second day of this 13th CompNet annual conference, which is taking place in Malta, discussing competitiveness and firm productivity in a disintegrating global economy. My name is Brendan Sacco. I am the head of the Structural Business Statistics at the NSO of Malta, and also the coordinator of the contribution by Malta to the CompNet firm level dataset. This morning, we shall be taking a look at another set of interesting papers, starting with the carbon pricing and economic performance. We know that the future of carbon pricing in Europe was high on the agenda of the European Commission presidency. Sorry. It's good. It was high on the presidency agenda by setting an ambitious carbon neutral goal at the heart of the European Green Deal. Despite the possible changes in the EU presidency, carbon pricing will always remain, always have a broader role in terms of firm efficiency. On this topic, I would like to invite Maria Garrone from the European Commission, DG GROW, to present her paper on the impact of climate policy on economic performance.
Sorry, I just want to try this device. Good morning, everyone. As been presented, I'm Maria Garrone from the Chief Economist team of DG GROW, the European Commission. And this morning, I'm very happy to be here to present a joint work that I've done with a PhD researcher from Paris Nanterre. This is an ongoing work, so every comment is more than welcome. And what do we do here is to look at the links between corporate performance of EU industrial firms and their decarbonization behavior in the context of the EU emission trading system. As previous presenter has done, I think I should add disclose that these views and opinion of this work are ours, and they do not represent the view of the Commission or the ADAME, the institute Alien are working. So our work starts off with the fact that although the EU has put in place one of the most ambitious and stronger climate policy, we're still projected to miss the 2030-2050 climate target. And therefore, we need to put more effort to increase this target. However, of course, one of the main concerns for intensifying this target is the risk of carbon leakage and the consequent losses in terms of competitiveness of our EU industry. And this is, of course, has been a very strong political and economic argument. And to mitigate that, a number of anti-leakage measures has been put in place and adopted hand in hand with climate policy implementation. And this took the form, for example, of the allocation of free allowances in the EU ETS, as well as the very recent initiative of carbon board adjust mechanism. So the EU emission trading system is the main tool for EU industrial decarbonization. Let me give a bit of a background to this system, although I'm sure most of you are familiar with that. It is a market-based instrument that was launched in 2005, and what it does is impose a price on carbon emission for the EU industry. He has gone through several phases. The first two were very low with stringency and also experienced very low carbon price. But it's in the third phase where the systems start getting more stringent and where we also experience higher an increase in carbon prices, especially in 2018. And this was mostly due to policy reform that were put in place to increase the stringency and also to address the problem of oversupply of allowances that was experienced in the previous periods. Now we're in the fourth phase in this year, and this phase also see further policy reform to increase the stringency and also way higher carbon prices. It is important to notice here that in this work that we have done, we focus mostly on the third phase, and this is mostly due to data limitation. However, this phase has been not touched much in literature. Most of the study covered the previous two phases, so it's in any case an interesting period to study given the policy development that I just sketched. Okay. Um, so the broad question that our work relates to is climate versus corporate performance. Are these two forces opposing forces? Do they go hand in hand? Is there a trade-off for firms between decarbonizing and increase their economic performance? And the literature generally outlines two main mechanisms. The first, we can call it the cost imposing hypothesis, that underpin the carbon leakage argument and that states that decarbonization is too costly for firms and tend to divert resources for productive uses, for more productive uses. On the other spectrum of the literature, there is the win-win hypothesis that state that decarbonization and corporate performance can go hand in hand. So firms can decarbonize and improve their performance through reduced material and energy input, as well as through green and productive enhancing innovation. And the later is very much linked to the argument of the famous Porter hypothesis. So our work is broadly related to this mechanism, and our research question is whether during the third phase of the ETS, firms' emission performance has impacted and how their corporate performance. The paper has several contributions. First of all, to analyze the third phase of the EU ETS. As I said, it was not covered much. In literature, we contribute to the empirical research on impact of decarbonization on firm economic performance. We also have a data contribution here. We extend a micro-level data set that connect financial and emission data at firm level. And finally, we develop a new measure of emission intensity that is based in volumes and not in values. The latter is the most standard metric of emission intensity that is used in literature, but we want to depart from that, as I will explain later. So very quickly on data construction, what we did here is we merged two main data sets, the European Union Transnational Log, that is a data set run by the European Commission and contain information on emissions and free allowances and a bunch of other data at installation level. And then we match this with Orbis, which I think most of you are familiar with, which is a data set that contains financial information at firm level. This match builds on previous work that has been done in the research community, and in particular a joint project of DigiGrow with GRC to match these two data sets. And what we have done here is to improve, extend the matching, and most importantly, automatize this matching so that will be yearly available for the research community. A secondary data set that we use is Protcom. As most of you are familiar, is provided by Eurostat and is a data set on production and trade of manufacturing goods in the EU. And what we have done here is to match Protcom with our data set based on firms declaring this activity. So with this data set in our hand, we have roughly 1,200 firms operating in the third phase of the EU emission trading system. Here you can see all our steps of matching. So the green line is the final line that we have where we use the reliable information from Orbis for the financial variable. And these represent roughly 75% of the all regulated manufacturing firms covered in the third phase. It's not a 100% coverage rate, but I would say it's a fairly good coverage rate. I mean, things can be improved, but there are severe data limitation on this matching. We exclude COVID period because, as you will see, our emission trading matrix is based on previous periods. So the COVID year is not very accurate, does not allow to give us a very accurate estimate of emission intensity in volume. Another important point here, we don't cover the power sector, we just cover the manufacturing firms. So, as I said, in literature, what is mostly used is emission intensity based on value. So you just take emission and you divide it by the turnover. However, this measure has severe limitation because turnover does not only capture industrial production, but can capture everything that is outside industrial production, such as marketing or services. So using this metric could underestimate the actual emission intensity because turnover will be deflated compared to the turnover of the industrial production. So what do we do here? What we want here is to have emission over production volumes. But of course, the problem is that data on production volume at firm level and also installation level are very sensitive data, not much available. So we have to work around a bit to create a proxy of that. And what do we do here? We make use of data that we have in our data set, the free allowances, and also the regulation, the EU regulation comes in our hand in this case. We use some factors that are stated in the regulation. In particular, free allowances are determined by previous production volume, and this is interact with a bunch of factors that are stated in EU regulation, which are product benchmark, cross-sectional correction factors, and transitional correction factors. So what do we do here is we simply recover volume at installation level, reversing the equation of for the allocation of the free allowances. So let me now quickly sketch the general approach. What we want to do here is to see how emission intensity affects corporate performance. So in particular, how emission intensity in T-1 affect corporate performance in time T. We loosely follow Trix and Co-author 2020. We add a bunch of control variables that I will pitch later. And we also add the firm fix and sector year fix effect to control for potential shocks that hit firm or sector specifically. So for our proxy of firm performance, we basically exploit all the variables that are in Orbis. So for the financial indicator, we use return on assets, profit margin, and EBITDA. For the economic indicator, we calculate labor productivity and material input productivity. Then we control for the following sector vector of firm-specific variable. We use turnover as a proxy of firm size, current ratio, which is assets over liability, as a proxy of financial health of a firm. We also include the number of new installation that a firm might have to control for potential composition effect. We add a proxy of firm level stringency, which is emission over free allocation. And finally, to control for potential windfall profit, we add a variable of net transaction value between purchase and sold allowances. Of course, this is a very naive approach that suffers from lots of endogeneity. First of all, reverse causality, so a firm that usually improve their economic performance is likely also to improve their emission performance. So the causality can go in the opposite direction. At the same time, there could be an unobservable shock, such a productivity shock, that might affect simultaneously both the emission intensity and the economic performance. So we might also suffer for simultaneity bias. So what we do to try to address this endogeneity issue is to build an IV strategy. In particular, we include a Bartik instrument, which is a shift share instrument at sector level. And in that, we follow Fontanier Quarter 2023. And what we do is we take the initial firm emission intensity gap compared to the sector average, and we interact this with the sector average emission intensity in T-1. Here is important to notice that when we compute the sector average, we exclude the firm that we are observing to comply with the exclusion restriction criteria. So what we do then is we plug our IV strategy to our naive approach. And then our final building block of specification is to add a competition setting. And what we want to do here is we want to control for the competition environment a firm operates in. This is because it can give an indication of the capacity of the firm to passing through the carbon cost or not. And to do that, we build two indicators of competition setting. The first is import intensity, a very standard indicator in literature, which is the size of the imports over the size of the domestic market. And an indicator that it's very used in literature is the intra-branch trade intensity as a proxy of product specialization. So very quickly on our results. So for our simple version of our IV, what we found here is that I show here both specification what emission intensity is based in volume and what emission intensity is based in value. Most of the coefficients are not significant. The only significant coefficient is for return on assets when emission intensity is based in volume, and labor productivity where return on assets is emission intensity is based in value. Then we dig a bit further into this relationship by adding the competition setting indicators. And what we found here is that competition matters in the sense that when we clean for this effect or we control for this effect, our link between emission intensity and some of the corporate performance are stronger. For example, the coefficient of return on asset almost double. The coefficient of labor productivity become significant, and also the profit margin becomes significant when competition setting is measured in terms of intra-branch trade intensity. Very quickly on our summary of our results, we analyze corporate impact of emission intensity on EU firm regulated during the third phase. As I said, there's been not studied much, and also on the entire EU. This is also not much covered in literature. We introduce a novel estimate of volume-based measure of emission intensity. What we found is a very small but significant impact on changing the emission intensity on some of the corporate performance variable, and in particular on the return on assets that is been significant throughout our specification. We found a stronger effect when we control for competition setting. And from a policy perspective, the small magnitude of our results might suggest that regulated firms still make a little effort to decarbonize. And this is because, especially in heavy industry, the decarbonization through new production process it requires lots of investment because decarbonization per se is highly costly. So from a policy perspective, the focus should be really given creating the right incentive to invest in effective adaptation and innovation in regulated sector. This is crucial to be able to achieve the target while trying to maintain competitiveness. Several action has been initiated, especially in the context of the Green Deal Industrial Plan, that goes in the direction such as the Net Zero Industry Act or the Critical Raw Material Act. And let's try really to find the balance between giving the incentive while supporting the reindustrialization of clean technology in Europe. I can stop here if you want, and I can take some over questions.
Thank you very much, Maria. I now invite Gianmarco Carriola for the Bank of Italy to discuss the main aspects of this paper.
Okay. Thanks a lot, Maria, for the presentation, and I want to thank the organizers for giving me the opportunity to discuss this paper because, first of all, it's a really nice paper, and secondly, I read many other papers that are related to the same topic, so I kind of expanded my culture in this subject. But let me go straight into the discussion, and let me just summarize very quickly what Maria said so far. Well, first of all, the starting point of the paper is that the EU ETS is one of the main EU policies for climate change mitigation. It's very important, but at the same time, we also see a trade-off between competitiveness and decarbonization, especially when carbon leakage is taken into account. So the main contributions of this paper are, first of all, the study of the short-term impact of emission reductions on corporate performance within the sample of the firms that are subject to ETS. It's not a diff in diff, basically. It compares high and low emission intensity firms within the EU ETS. Secondly, it extends and improves the merge between the UTL database and Orbis. There is a new volume-based measure of emission intensity, and the paper also studies how the performance emission nexus is influenced by international competition and product differentiation. So, first of all, congrats, because it's a very rich and promising working papers, and I'm looking forward to seeing where it's going to end up. I think the topic is super relevant, and I think probably the best thing about the paper is that there is massive data work behind the paper itself, especially when it comes to the UTL Orbis combined database, the new emission intensity indicator. I think all this stuff is going to be really useful to other researchers in the future. I have a few comments mainly about the identification strategy. So basically, your model can be written somewhat like this. So you have emission intensity, you have corporate performance at the front-end level on the left-hand side, and lagged emission intensity on the right-hand side, controlling for a bunch of firm-level covariates and a bunch of fixed effects. Now, the problem that we see is that emission intensity is probably endogenous with respect to corporate performance, because either reverse causality, or what I was thinking when I was preparing the discussion, I was mainly thinking that there might be some productivity. I was thinking maybe, management quality shocks, this kind of stuff that on the one hand increase emission performance, and on the other decrease emission intensity and increase corporate performance. So there might be some kind of downward bias. The identification strategy indeed relies on a Bartik instrument, which is built as the share of emission intensity at the firm level over sectoral level in time zero, multiplied by average emission intensity at the sectoral level, excluding the firm, in time t. Now, the exclusion restriction is valid as long as sector level emissions are exogenous and let's say the error term is not correlated with the initial emission intensity of the firm. These are two separate questions. On the one hand, I saw in the paper, but correct me if I'm wrong, that you do not control in the ID strategy for sector time fixed effects. Maybe because there is some kind of, collinearity, this kind of stuff, so you cannot do it. But this poses some questions, because I was thinking that, for example, there might be the sector time specific technology shocks that might, that's just to say that we cannot really take for granted that the sector level emissions are exogenous, but let's take it for granted. Another thing I was concerned with is this exogeneity of the initial emissions, and the reason is that you have a short panel. Let me illustrate the problem with this. Basically, we can rewrite the error term as the sum of an endogenous component H and an exogenous component epsilon. Let's assume that epsilon is well behaved, so we don't have any problem. As long as the endogenous part H is correlated with the error in time t, is correlated with emissions in time t or t minus 1, whatever, but is not autocorrelated, we don't have a problem. But This is not true if the shocks, the unobservable shocks, are persistent. And there might be a case, I can imagine that productivity shocks, management shocks, this kind of stuff are relatively persistent. If you, for example, make the hypothesis that they move like a stationary AR1, you will see that you can write the shock today as a function of the shock in the initial time period, scaled down by some parameter delta to the power of t, which is between 0 and 1, plus some noise. So you have a correlation between the error in time 0, you have a correlation with between emission intensity in time 0 and the error today, mediated by this autocorrelated structure. So what's the point of all this? If the firm level shocks are persistent and the panel is short, which is T is small, the Bartik instrument might not solve the issue. I saw that you cite Fontanier. The main difference between Fontanier and your setting is that the data for Fontanier go from 1996 to 2019. Your data go from 2013 to 2019. So it's quite a different setting. Then the other thing is that Fontanier's analysis is mainly about the impact of price on some other stuff. And price of energy is also determined on the international markets, also at the firm level, but there is more of an exogenous part. So I think that Bartik maybe is not super efficient in solving this issue. Of course, I'm not saying the analysis is wrong or you should throw it away. Well, I would suggest, there are two ways to go about this. One very expensive way and a cheap way. The very expensive way would be to change the setting, investigate if there are some discontinuities in the regulation that can justify, I don't know, some exogenous variation. That would be probably the best, but I'm not sure it can be done, so I'm not advising for that. The other thing is that I suggest to expand a little bit the section of the paper that talks about the identifying assumption, in particular the exclusion restriction of the instrument, and maybe provide some robustness. If the concern, for example, but this is just an example, is autocorrelation, you might try, for example, to rerun the regression on the last few years, instrumenting for the initial year, because we might try to argue that the 2018-19 data are less correlated with 2013 than 2014 is correlated with 2013. So if you find that your results are robust, selecting a sample which is arguably, less correlated with this kind of stuff, probably you're better off. And then other than that, I have some additional comments. In particular, I saw, as I already mentioned, that the set of fixed effects in the text includes the firm and sector time fixed effects for the OLS, firm and time fixed effects for the AV. I guess it's because of some kind of collinearity between the variables. The only thing I would suggest to present the OLS results with and without sector time fixed effects, so you can compare the OLS with the AV and you can investigate better the sign of the bias. Secondly, that was something I mentioned at the beginning. I would have expected an exercise when you compare ETS and non-ETS firms in a definitive-like framework. So I was wondering why you decided to do it within ETS rather than ETS versus non-ETS firms. I guess it's because data availability, something like that, or and then, two very, very last things. As you mentioned in the paper, this is a very selected sample of large firms because the firms are subject to ETS matched with Orbis in high-income countries. So I was wondering about the external validity of the results. And finally, but this is of interest for me as a trade person, is it possible that some firms decrease the emission intensity and increase the corporate performance through outsourcing some tasks to developing countries, which is basically the issue of carbon leakage? Is there a way to control or to study carbon leakage? Because I think this is would be super interesting at the firm level. And yeah, that's it for me. But thank you again. This is a super nice paper.
Thank you very much, Gianmarco. Okay, the last slide of Gianmarco. And reaction, Maria, or should we go to the questions from the audience, please? Questions, Richard.
Thanks so much for the great talk and a great discussion. I have a question about the literature.
Yes.
this win-win hypothesis. So the way that I think about climate policy from the firm's perspective, it's like adding a constraint to a problem, right? There's no way that adding a constraint to a problem can ever increase the value of the function, right? So this win-win hypothesis doesn't make much sense mathematically. So do people really believe this, or is this wishful thinking?
Okay. Wow, a lot of
Lawrence.
questions.
I mean, isn't there an intermediate thing to test whether the ETS system actually reduces their emissions rather than jumping to corporate performance? Because I think,
Sorry, then repeat the question.
I mean, does the ETS system actually reduce emissions of the firms? It just seems like that's an intermediate step before jumping to firm performance. I'm sympathetic to what the previous questioners asked. I mean, if you had a constraint, it's hard to believe that it actually improves firm performance. Because I mean, the experience in Canada is that we've raised the price of carbon through taxes to $80 a ton on consumers, and it's having very little effect. And so the takeaway is that the carbon price has to rise significantly to actually change behavior.
Yep.
So that's my question.
Thank you, Lawrence, for your question. Carlo.
No, I had an issue on identification, but I think the discussant made a great job on that. So, I mean, that's more than. No, the questions I was wondering were one is whether I like this new volume-based measure of emission intensity, and whether you can provide any comparison versus traditional old measures. So, what do we gain from this? How does it compare over time if I would use one or the other measure? Because I would be interested in knowing what we were missing versus what we are gaining with this new measure. And second, which is more of a sort of your feeling, phase 3 has had an impact on prices. Essentially, I think it's a doubling of prices towards the very last term, very few years before switching to phase 4. Phase 4 increases prices 4 folds, roughly 4 or 5 folds. So I wonder whether we might expect much larger effects, clearly having data on phase 4. Thank you. I think Eric.
No, so I like the comments also. The great paper, very important topic, and the comments were right to the point. But when I'm thinking about the data constraints, I mean, in the statistical agencies, you've got the firm level Prodcom, but we've also got stuff on the financials. We've got stuff on the trade. So there you can really look at all these different leakages, the ones that you mentioned about firms reducing production of certain things and starting to import instead. The other one is the differences between at the boundary of when a firm becomes ETS and when not. So I'd be expecting to see bunching right below the threshold, where the distribution of firms below the threshold starts increasing and lower than that. So your effects on within firm efficiency should be well above that threshold. But you've got all the experiments you can run with the changes over time in policy, the changes across countries, and the changes and the diff in diff of the firms. So it would be great if the ETS data were sent to every statistical agency to link to their business register.
Yes.
It solves this,
Yes.
problem solved. And I think that would be a great service to have the EU send this data to link to the backbone.
Yeah, I know.
Thank you, Eric. We have another question there.
Thank you for this nice paper. We have also conducted work on the ETS at the European Investment Bank. I have two questions. One is on the missing link between the ETS and the economic performance. You don't speak about investment, so maybe you should bring it to the story, because what you want to avoid is the repercussion of the taxation on prices, but the nice effect that you want to get is more investment in energy efficiency and energy change investment. And the second question is about the linearity assumption underlying your scheme. We know that it's relatively minor, the level of ETS currently. We know that there will be a push. So I think this can trigger a change in the behavior of corporates. So far, they can pay the tax, but at one stage, the tax will be so elevated that they will really have to shift their production function. So this, you don't speak about that, while you have an element in your presentation, which is about that, which is the stringency indicator.
Yes.
So for example, I would have mixed this with the behavior of firms more in a more structural way. You have this information, you could use it. If you collect money through the ETS, you have less incentive to invest and to go green than if you pay money to the ETS system. Thank you.
Thank you. I think, one second.
Yeah.
Work. Okay. So I have two questions, one econometric, one policy. So I don't know if you control, I could not follow this in the sample. I don't know if you control by firms who exit. That's a key issue in the productivity literature. And we may be painting a very rosy picture with the surviving firms, who are the ones who perhaps are overperforming, while others are relocating somewhere else in the world. And second, I don't have the opportunity to talk to people at the commissions. Do you really believe that we need to strengthen the standards? One thing is that we measure this, and we are measuring in terms of reduction in emissions. Now let's look, sorry, I'm a micro person. Let's look at what's going on with data centers. For Google data centers need the electricity power of a nuclear plant, more or less. We have the oldest transmission network in Europe. It needs, according to, I was just browsing, we need in the order of a 1 trillion euros investment in the next decade if we don't want the network to collapse. That's about the GDP of the Netherlands alone. Is it achievable?
Okay, I will try to answer to group questions, but of course, if I don't address now, I'm happy to discuss bilaterally. So first of all, thanks a lot to Gianmarco, because this is a very good point that you raised, and we were aware we have severe data limitation. First of all, because using this value, and then address also the question of Carlo, is using this emission intensity based on value. We use the EU regulation, but the EU regulation changes from third phase to the fourth, so the two things are not strictly comparable. To do that is another massive data analysis that at this point this poor researcher, because I must admit is her work, has to do so, and the work is ongoing, but the idea is to extend and to then be able to compare. Why we want to, what is the rationale to go for that type of measure, as I explained, is really to try to capture the industrial production. And it's already problematic, the fact that when we match installation and Orbis, of course, we don't have all the installation of a firm. The ones that are regulated are only a part of this firm. And we try to clean the data set. For example, we call it NACE filter, to just take those NACE code that are strictly related to the ETS. So we really try to identify firms that has this link with ETS. We cannot also analyze the ETS per se, the effect, because the diff and diff is not feasible. The only person that does is the Chelepret, which has a very specific data set with emission for regulated and non-regulated firm. We don't have that. So that is, we cannot use this identification strategy. Definitely, we can try to do 2 and 3 years analysis. Of course, the sample is very short, so we are aware that we do what we have, basically. Fair point on that we should really try to match better emission intensity data with a cross-sectional country, that's for sure. Win-win hypothesis, we really believe that. I mean, there is a literature on that. It's mostly focused on longer period in terms of more of innovation, as the EIB as highlight. So really to try to identify the channel of innovation of the firm. So, but again, for example, the Shelley Pareto 2022 finds some positive effect on productivity of those firms. Again, in the first two periods where the stringency was not that high. So the fourth period is really important to understand how, when you increase stringency, how firms react, whether they can actually adapt. And this is also linked to your point where, yeah, we are we increasing stringency, but how, as from a micro level perspective, that is problematic indeed. And we are aware of that. At the same time, climate change is real. So it's, and the Commission try to always compromise the different goals that a society has. Let me see. I think I more or less address all. We can definitely control for exit. That's for sure. And one of our venue of research is indeed to try to integrate data on patent, for example, or on R&D to see whether there is this mechanism. But again, our analysis in the short-term impact, while I suspect that it makes more sense to have a long-term impact, because decarbonization goes through a longer period than innovation is a long-term process.
Thank you, Maria. We have some time for another question. Eleonora?
A very quick question.
Yes.
The impact of firm size of on the emission intensity, because you told about the use of turnover
Yes.
as a measure from size. Could be interested to see the effect of size in terms of employment, because
Yes.
if I understood well,
That is a very good point. The reason why we didn't use it is that Orbis is not very good on employment, and also, I mean, as far as I know, the way how they include the employment figures are not necessarily very well comparable. So to avoid that risk, we want to.
But this could
Yes,
be an issue,
that will
of
be
course.
definitely a point. Yeah.
Thanks. Thank you.
Thank you.
And thank you for your questions. We now move to a special session, actually, which is a direct application of the CompNet MDI, the microdata infrastructure. It will be a presentation on the work done by Professor Eric Bartelsman, Rito Parma, Vishwanath, and Elena Sponga.
All right. I'd like to thank the organizers for inviting me and the hospitality here at the Bank of Malta. It's been great so far. Just beautiful being here. I was a late addition. I guess someone dropped out. Someone got kicked in the nose and couldn't make it today. So I'm here to take over. Let me share my screen. I'm kind of doing this live. I've always been told not to do that because accidents happen in presentations when you don't demo everything, but you try to do it live. So let me share my screen. That's what I was afraid of. Need to go and give Microsoft Teams my authorization and use password. See, this is already quit and reopen Teams. La-di-da-di-da. Never do a live presentation. And hopefully I can get right back into the presentation. Except join. Yes, there we go. Am I in the presentation now? Sorry. This is very, very embarrassing. I was told really never, ever to do this. Yes, I know. Just 1 second. Continue, join the Teams app. Yes, here we go. Allowed, open. Join now. Yes. Correct? Yes, you can see me multiple times now. Did I just hit leave? Oh, this really never happens to me. And even more embarrassing is going to be when I start my show, I share carefully and I share my windows. Built-in Retina Windows 15, yes. Here we go. Okay, unfortunately, this is a slide from 24 years ago. I dug it up yesterday out of my archive, and it was my first presentation on cross-country linked microdata-based economic analysis of policy themes. So that's not what I was going to do today. We're 24 years later. We've still got a cross-country setup. What we planned there, and Stefano Scarpetta was my collaborator on this, and lots of people in this audience and other central banks and statistical agencies were part of this. Bunch of hobbyists back then. And I've got to say now in CompNet, we've got the 9th vintage of a kind of a professional organization doing what we laid out back then. And it's gone through iterations, the funding from the EU, funding from the World Bank, funding from the OECD, funding from the Eurostat, funding from the ECB, now funding from different groups in the Commission, F2020 project. It's just been a long ride, and I'm just happy to say that it's available now, and we're seeing what we can do with it. So now I need to share another window, which is the real presentation. Okay. And this has taken over my screen. Oh, here we go. Of course, you really should never do a presentation live. Because everything I had set up disappeared. So microdata infrastructure from a researcher's point of view. Trying to get the audience, people working with microdata, working with CompNet data, working with single country firm level data within a statistical agency, working outside, trying to link administrative data sets with publicly available data. We all kind of know that this is a lengthy process and very difficult. So it's kind of not unlike, you know, shooting off a rocket with scientific stuff in it. And you just hope that it goes right. There's lots of planning that goes into it. So I made this yesterday. I asked ChatGPT, can you make a picture of a reusable rocket on a platform, blah, blah, blah. And it came up with this, and I kind of like it. So I got my productivity boards and research institutions. I've got this, something that looks like microdata infrastructure. I've got kind of, I don't know what the UK flag is doing there. I guess this was trained pre-Brexit. I don't know. Anyway, so the research with firm level data is difficult. Public sources such as Orbis are expensive to use and limited in use, right? You can link in your one data set, but then you don't have the firm level outcome. You don't have the firm level product-based trade. You don't have the linkages of the firm. Well, you do in Orbis have the linkages of the firm with its parents and globally. So there is that. But you're missing lots of stuff that would have been handy to have in the analysis. Statistical agencies are really set up for that. They have a backbone, which is both a statistical frame and it's the register of firm entry and exit and the links to employment and the links to lots of other administrative stuff. So it's the ideal research place to do the kind of work we want to do. The problem for a researcher getting in there is that the startup costs are really high. It's hard to get access. The rules are different in each country. Sometimes you have to go travel to some basement somewhere. Sometimes they have dongles that you can put on your own laptop and work. That's easier. But getting the data to work, I've seen generations of PhD students and postdocs spending months and months and months. Martin is laughing there. You probably spent months and months the first time you did this. And it's, you know, I would tell someone on the assistant professor market, don't even try this because you won't be done by the time your tenure clock is out. It's difficult. Further, the data can't be combined across countries. So each country has its secure data set. You know, the kind of the official rules vary across countries, but none of the EU statistical agencies let you take out their data to combine with another country. So that is hard because for trading, for emissions trading, we're wondering whether different countries with different setups and different kind of institutions react differently. We're wondering whether growth in countries that have different employment regulation or different paths of industrial policy have different growth responses. You really want to do that cross-country comparison to find out what the institutional differences are that are causing the policy. So MDI improves this situation. Part of the stuff is to document and harmonize linked firm level panels. And I say across countries, you don't link them across countries, you link them within countries, but across countries, you do it in the same way. So we've got really well documented data at statistical agencies. A researcher who's done this work in one country can just take their knowledge and apply it to another country. It's identical. We're planning regular kind of launches of a rocket that has payload. The payload is the researchers, is your analytical plan. You've got an idea to do. It gets packaged in this rocket. The rocket gets sent to each statistical agency, and in that agency it runs, and it returns output, which you then can combine across countries. So if you do a clever research design, you can get exactly those moments out of each country that when combined give you the identification together with other cross-country variation to do your policy research. And sometimes we're wondering in the future which countries are going to allow kind of this rocket. So, for example, one of our partner countries, Austria, has a rule that each project must be predefined. And so our rocket will have combined projects. And so probably that will not be allowed to land in the Austrian thing. But if we harmonize their data at least, you can go with your project there and send your code running the first day. You don't have to spend a year organizing your data sets. Another possibility we're thinking is to have the European Science Foundation say, this is a project on emissions trading and firm growth. We allow researchers to go for the funds. We select 3 or 4 projects, put them in a rocket, and then we sell it to Austria as an ETS rocket. So we're looking at how this is going to go forward. We don't know yet. But the important part from the researcher's point of view is you really want to find this MDI is really useful if you have a question that needs cross-country comparisons for identification. If you can solve your problem in one country, you don't really need this. It's also good for research projects that require some kind of firm level or micro aggregated from firm level data for identification. It's also really strong if you have the need to link across different domains. So energy use and finance, or innovation and labor, or industrial policy and firm entry. But we've been hearing examples of people interested in this stuff. So I think that's good. The other one is it's handy if you need data from outside of a national statistical institute. So part of the payload can be a data set that's shipped in. So an ETS program, world input-output data, EU CLEMS data, other data sets can ride in on the rocket and be installed at the statistical agencies. The ETS is a bit difficult because someone has to do the linking, and that's usually only feasible within the statistical agency. So there are examples of our CompNet team right now, and I'd say the sub-team for microdata infrastructure in CompNet. We have some examples of research out in the posters. There's also other posters, but I'm going to highlight some of the MDI work being done right now. Please go buy the posters if you haven't yet, because I really can't do them justice in a few minutes. So examples from the CompNet poster sessions. There's a poster on productivity transmission in the value chains. This is stuff where you're wondering how firms in a country respond to the best firms in that country, but also to the best firms in the countries that they sit in global chains with, the frontier of the firms in other countries. So Elsorito and Natani have a poster out there looking at productivity diffusion across and within the countries, looking at catch-up to regional value chains, turns out to be an important channel of longer run growth. But you can also look at immediate impacts of shocks in the chain. Right now, they've tested that in Finland, Netherlands, and France. So their code is up and running in 3 different countries. We're hopefully very soon going to add a few more, and I'll get to that in a minute. So here's the picture that's worth 1,000 words. I recommend you go, but you can kind of look at the short run response. That's always the top of the set of bars to the local shock. And then the other one is more the catch-up response. And it shows differences across countries during COVID. So once you add more countries to this, you can start disentangling how, why it is that these parameters vary across countries. You know, you try to tell stories from this. On energy prices, that's a bit more difficult because the standard collection at statistical agencies and energy prices really varies a lot across countries. Right now, Rivera has a, pardon me? Marcel, sorry. I'll never forget the last name and the 2024, it's famous combination. Has a paper on energy prices done in France right now, but we've been collecting the metadata to set up this analysis in other countries. So we're going to be able to do something very similar in Austria and Germany, I hope, and Portugal and Slovenia. We've linked in the ProdCom data, which is firm level products production by product type in expenditures or in sales and in units and unit values. So that data, if you have all the firms and all the products, think of the big matrix, we have at the end column, we've got the total energy intensity of the firm. We know how much energy they use, but we also have their product mix. So you can statistically filter out a reasonable estimate of product energy efficiency. So it's not firm energy efficiency. You can try to get product energy efficiency, which gets the denominator right here because it's the product, it's the quantity produced of that product. And then you can start looking over time. Once you have this type of data, you can see when policy changes come in or ETS changes, you can figure out what happened. So right now, the work looks that when energy prices go up, firms do save on their energy intensity. And you can aggregate this ProdCom back up any which way. Here it's aggregated up to 2-digit industry, but you can aggregate up to firms that trade externally, that export, and those that don't. You've got lots of different variations. Next paper is Andraculo, Vader, and Miranda. Do I remember Andraculo? I was in this PhD committee last week. So, yes, I do. Congratulations. There, the idea is to look at unexpected changes in profitability and look at extensive, intensive margins of firms' responses to their inputs. To do this, you need really good productivity estimates at the firm level. You need investment data to get good capital stock measures or good balance sheet data to get capital stock measures. And then you need to compare the intensive and extensive responses to shocks. Right now, it's running in Netherlands and France. And again, I see no reason why this wouldn't run today in Finland. And we're very close to getting the other. In Portugal, it should be running, and there's little glitches we haven't figured out. Maybe one of us actually has to go to Portugal to help out. What's really fun about this is that people have been working on this issue for a while. When you look at the reallocation literature, it's all about wedges between marginal products and input costs. And sometimes people say it's misallocation, but it could also be that there's adjustment costs. Firm gets hit with a shock. They've got a workforce. They spend a lot of time collecting all these employees. They get hit with a negative shock. They don't want to get rid of them right away. Or it's very costly to get rid of them right away. So there's ranges of inaction when there are adjustment costs. And the left panel here shows the probability of adjusting, yes or no, given the size of the shock. And you can see U-shaped curves, which is what you'd expect. But here you can look at contrast between France and the Netherlands. And probably the costs of doing a downside adjustment in France are really high. So given the shocks that we observe, you don't see many firms deciding to misadjust. So this is like a great diagnostic for finding out what are frictions in input markets for reallocation in a country. The center one gives you the steepness of in the intensive margin, given that you do adjust. And here, again, the slope can tell you about the fluidity of the changes. And then you can look at these types of margins at a business cycle frequency and see if the business cycle responses are different. So it's, I mean, again, I would say if I were, the economic physician to the Minister of Finance and Economic Affairs, these are the diagnostics I'd want to get to figure out, are things running as they should be? So I think this paper is great. Russ Cooper and John Haltwanger have been working on this for the US for a long time, and we got some really rapid results here. I mean, their paper isn't out yet, but it's really nice. I've been working with a visiting PhD student, what's his name? I know that. Okay, Danielle, and myself. No, it's been a great collaboration. So we use productivity estimates from the firm level data. We've linked in again this ProdCom. Danielle's been doing a great job. The ProdCom is 6-digit product groups. There's like 6,000 of these products. The codes, they're officially harmonized according to the Eurostat, but in practice, each statistical agency has their own version of this that changes over time. And he's come up with a great methodology of moving forward and cleaning over the breaks so that we can have a within country and a cross country harmonized ProdCom. Months of work, and we're codifying it so that everyone can use this. We've linked in global input output data and linked in global 6-digit trade data, comp trade data. The bottom line of the paper, new technology lowers the marginal cost curve. So lots of fixed costs, lower marginal cost, but it also flattens the marginal cost curves, meaning that input costs don't go up as much when you have shocks. And after controlling for heterogeneity in the demand side, because we want to adjust for differences in markups versus differences in marginal costs, we can actually see a macro level flatter Phillips curve. We've done this now for Finland, France, and the Netherlands. We started for France and running it all in France, testing it for weeks and months. It took hours, or it took days to move it to the Netherlands and hours to move it to Finland. So again, the methodology works and runs. So here, these are our marginal costs. Danielle, after discussing with us what should we do, came up with a clever algorithm to cluster firms according to the demands they face and their supply and production characteristics. When you lump these and show kind of the cross productivity or cross production categories, you can see that the most productive firms have much lower marginal costs and much flatter marginal cost curves. And they're also much larger firms. And you can see the ratio of marginal costs, and you can see the distribution of firm size on the picture and the slope of the marginal cost. Think in your head a demand curve across each of these lines, or a marginal revenue curve, and you can have 5 demand categories. We've got 5 production categories, 3 demand categories. You can think of 15 little Tinbergian supply and demand curves in your market, and you can kind of see what's happening. The bottom line with this is that when you estimate Phillips curves for countries and you interact the coefficient by production category, you see that the Phillips curve is much flatter for the more productive firms. When you aggregate this back up to the macro level, we get a much tighter estimate of a time varying Phillips curve that you could use for policy. Now, I'm still debating about these standard errors and how we actually get that. And I bet by the time we're done, they're going to be much closer to the pink ones. So anyway, that's our work. Please go and talk to the authors and co-authors who know a lot more about this stuff. To me, the bottom line is that you got a research question. If these micro data sets are harmonized at the statistical agencies, then you can replicate this work really quickly. I mean, it's really not that hard. Writing the code initially is hard. You need to know what you're doing. But if you get the statistical agencies to work with us in documenting their data sets and allowing this harmonization to happen in this way, it becomes really easy to do the cross-country work. So here's the architecture of the MDI system. Kind of in the center is the access to the data. So we have countries that allow remote access. Authorized researchers have a dongle or a fingerprint reader or a secure connection to the microdata. We have remote access in countries where the research partner needs to be sitting in that country. So that's Finland, and I expect that's going to be in Italy as well. You need to be in Italy, but we don't know. We'll have to discuss that. And in Portugal, it's remote execution. It's someone at the statistical agency doing it. So that's the access to the data. Top left corner is you guys, the researchers. You come up with a project. You write the project payload code. How do you write that? Well, we'll get into that, but we're building a mock data architecture where you can play with your code in mock data in case you don't have actual access to a statistical agency to test it. That code gets sent to the CompNet MDI network. We package that code together with the metadata preparation of the statistical agencies. We package that all into a rocket. We send the rocket to these countries, and we generate output that's identical across countries to repackage to the writers of each module. So at the end, when the rocket lands, there's a package for the people doing global value chains. There's a package for people doing Phillips curves. There's a package for people doing energy, bundled across countries. So that's the basic setup. When a new researcher comes in, what do they need to do? Well, you need to check the catalog for definitions of data sets and variables and check availability across countries. You need to view the metadata. So this was the metadata from 2000. Okay, this is the level of what we thought was needed for harmonization in our first round in 2000 and 2001. Now we've got much more extensive stuff. So we have the metadata catalog, and the metadata catalog has the microdata that we're using MD for almost everything: metadata, microdata, architecture, microdata, harmonized data set. The data sets are the harmonized data sets in each country. These are the names of the harmonized variables. And at this point, this is the availability of the variables in each country. And here's some information about what type of variable it is and its domain, you know, what valid measures do they have, what units do we measure them in. There's other data also, you know, what's the appropriate size of this, how many variables have missings, et cetera, et cetera. So we document that, and the user, there's a little shiny app widget for those who know that you can open this data set, and there's a little check mark next to it, and you just check which variables of this you want. Each payload person, together with the code, sends this list of variables. We put them together, create the superset of all these descriptions, and we go and gather the data for the rocket to run all the analysis. I mean, it's really quite simple. Okay. So you select the variables to use for the payload. You assess whether the data meet the research question needs. So that's a testing thing. After you've selected, you run the code in a country or on the mock data, and you see whether it works. You see whether you need auxiliary data. You discuss with us how to package that, and you test it. We're actually also building the mock data set to mimic each statistical agency's technical platform to see if it might be too big to run or whether the system can handle what you're doing so we don't get runtime errors. The firm level work, so it's selecting the data sets. It's view samples of reading the microdata, merging, regressions, aggregate, export. So we've got all these functions that we build. And for example, we have we're building a package that's going to be an OpenR package. So, and these are all the tools we have now. So let's, for example, say, make MDI productivity. Estimate. Well, let's estimate markup. So we get a little thing that estimates markups out of the Looker. And you can just call that as a researcher. There's documentation on what variables you need and what flags you need to set and what options you have. We have a thing on, where's my make product? I don't see my productivity Yeah, anyway, it should be in there somewhere. There's stuff on exporting data. This is actually kind of nice because each country has disclosure rules for what data we can export. This will look at the analysis you did and pre-compute all the possible flags that the statistical agency can see if there are problems with disclosure. You as a researcher just have to make sure you never get anywhere near that limit, but this is also to help the statistical agency do the work they need to do to allow things out. I'm expecting, other than, in CompNet, we pull out big data sets with lots of moments. The idea here is much more limited. You do an analysis, you might have some moments at a high level of aggregation, maybe between firms, the different technology categories, but 5 categories, not 400 industries. So I don't expect problems, but this tool, you cannot, no data will leave the rocket unless it's been exported with this function. So that's one of the rules. So we have something on aggregate. This will do all kinds of aggregations, whether it's percentiles, quantiles, sums, means, numerical things, looking at Booleans, different options. But again, it's to collapse data in a very easy way. Joint distributions we can make, etc. So that's kind of what needs to be done. The cross-country work comes when you prepare the output. So the rocket kind of lands. Each statistical agency has a set of output. The export function not only provides the disclosure flags, it also tags each bit of output with which module it came from, what's its description, what's its dimensions. Once the statistical agency sends that to our secure MDI environment, we repackage all the output to ship off to the module writing team. And then they do their further analysis. So the researchers have 2 steps. One is the stuff that's done at the firm level, and then there's the stuff that's done comparing across countries. Am I on time? Okay. The details of the rocket: statistical agencies download and install the infrastructure. They prepare the metadata. They fill in this program we call Countdown. It lets them prepare all the flags they need to have. One flag we, for example, have is we have tagged the version of all the software and all the modules in a GitHub. So when you send your paper to a journal, this hash key is the documentation of what data you've run on, what version of our tools you did, and what version of your code you've done. Because with this, we can retrieve for any future reproducibility, we can retrieve everything you've done and how you've done it, which I think is a really nice feature to have. Journal editors are getting worried each time they get a paper they just have to trust the researcher that they know what they're doing. And this is going to allow for a reproducibility. Okay. So they fill in this information and then they run the liftoff module, which, just because I want to show something really complex, here's the liftoff module. It sends the rocket up. That's all it does. So quite easy. And then the rocket reads the R packages, reads tools, reads the metadata from the country itself and the metadata from our data sets, and it merges them and documents them. And then it does what's really important. It's the harmonization step. Units of observation, but also how to link and how to change values. And we've got a really cool system with kind of a hierarchy of things that need to happen. Revalue is changing the number, exchange rates, units of energy, date values, whatever else. The R function is in the metadata to do the translation. We have recoding, is to take like code books, yes, no, or Likert scales or country groups, and it recodes them to the harmonized value. Reclass is taking anything that's an official classification, NACE, NUTS, product codes. They change over time, they vary across countries. This does the concordances. Remapping changes the names, and redefine merges variables to create new variables. So here's an example from the metadata, just a couple of lines for Slovenia. Here's some variable razet, which just becomes firm ID, and it's a remap. Here's something that's a revalue, which is exchange rate stuff prior to joining the euro. And here's a redefine these two variables turning to fixed assets. And here's something similar for the Prodcom data. Again, there's the NSI name of the variable, there's the MD name, and there's the method of remapping. I mean, it's surprisingly simple. So I think we'll leave the tool types to the tool types in the audience. If you want to know what all can you do with our stuff, you know, here's documentation on and blurbs on everything. The whole documentation is live, so as we change it, all the documentation and PDFs and displays change automatically. Even this presentation will change as the metadata files get updated. So that's really nice too. Thank you.
Thank you very much, Eric, for this very interesting demonstration of the MDI. Very interesting, especially for NSIs. And now we will open the floor for questions, and we can start with Martin.
Thanks for the presentation. It's a fantastic project. You focused a lot on the use of CompNet to test hypotheses, but it seems that a big potential avenue for research with CompNet data is actually for macro model quantification. Because when you quantify a macro model, you need to do structural estimation, which involves matching moments. And the beautiful thing about CompNet is that the number of moments you can use is exploding. So it would enable you to quantify macro models on many more countries than just the one country that you've spent months getting data access for. And so I'm wondering, is this something that you guys are actively talking about? Are you reaching out to macroeconomists to do more of this? And also, have you considered the impact this is going to have on the incentives for countries to join you, right? Because this means that any cool macro model can now be very easily quantified with country-specific data.
Collect more questions or go? Sure. Should I answer this or wait for?
Any more questions?
So in a way, the CompNet database, which is these original micro aggregated moments, they already essentially meet the needs of the modelers. I mean, we started doing this long ago exactly for this purpose, to grab these moments and use them. So the paper I did with Scarpetta and Halterwanger that we started in 2003 and it came out in 2013, used moments like this to calibrate slash simulated method of moments kind of optimization to find the parameters of the model. We did that, and so now people are doing this a lot. The MDI essentially goes a step further, and it lets you target your research to things that we haven't captured the moments for. So CompNet's noticing lots of, and it's been growing and expanding over the years, more countries, but also more moments. But sometimes there's some new analysis that you really want to customize what you're collecting. And this will allow you to send the stuff in to customize. So for the monetary policy, for the Phillips curve project, we needed firm-specific price indices, because the Phillips curve at the firm level is its price. Where do we get the price? We got that from Prodcom, from all their products, and creating a Lesper's, or I guess it's a geo-mean index of product price increases for each firm. CompNet doesn't have that. So we needed to, so the CompNet is going to solve a lot of people's work. Yesterday, we saw the story on intangibles and productivity, which was Olga there. Really nice piece of work. CompNet is great for lots. This is an add-on for those who want to delve deeper.
Any more questions, please, from the
outside audience? Any?
Do you have questions from outside, please? Carlo.
No, just an operational question. Thinking about Italy, as you know, the access to Italian data is related to physical presence of a researcher in an authorized lab in the country. Though these labs are now widespread on the territory, so major cities are covered. So how would that work in that case operationally?
So what would have to work, and this is kind of going to be legally a little bit difficult, we're going to need a partner in Italy who runs this, but who's also willing to send the rocket with other people's code. So we were talking in Denmark, where they have a similar system where the researchers need to be in Denmark at one of the regional centers. And he was saying, look, I have a legal arrangement with the statistical agency. If I do something wrong and take out data I'm not authorized to take out, they cut off my access. You know, first warning, second time you're out. And he's like, this is my living as a researcher. I'm not going to run someone else's code. So this is something we need to work on. Part of what we've done with our rocket is to force researchers to really structure their code in a simple way so that if you're running this rocket, you can look at the code and make sure, oh yeah, this is what it's doing. I understand that because it's aggregating, it's running a regression, and it's exporting the output. I understand exactly what it's doing. And then you might be more willing to do that for the network in exchange for your code running in 28 other countries.
But maybe the MDI infrastructure could run this preliminary check, making sure that.
Yeah, so I think, we don't know where it's going to head later, but if there is a funded, like a European Science Foundation funded organization, then indeed there would be a call for projects based on some theme. Researchers would apply, would send their code, and yes, we would then check the code before sending it. There would be an arrangement with some, but still we would need a partner. One of our network had to be at a Italian research data center. So even if that doesn't work, though, if the Italian Statistical Agency's Research Data Center were to install our MDI infrastructure, the researcher could go there and have familiar data sets, familiar variable names, familiar setup, and just be able to run their code. So that's already a gain. All right.
If there is no other questions, I think we can pause here for coffee and resume at 11 o'clock.
And so thanks to the MDI team, I've been writing hard on that, Elena and Ritu and Marco and Leonardo.
Thank you.
Danielle. It's been a wild year and a half running this with them.
And continue at 11. Thank you.
So my name is Manuel Tabone, economist, director responsible for business sector and regional statistics at NSO. I've been in this post for the past 5 years and a half. I've been working at NSO for the past 23, 24 years. I moved twice outside on NSO on secondment, but I'm always back at NSO. I was involved also previously in tourism and transport statistics, and my first experience was in national accounts for the first 5 years. So I will be chairing the fourth session, Growth and Innovation. I'm not sure whether to call the first paper and then go for the next. So I call everyone. Paper 7 is the aggregate effect of decline of disruptive innovation by Richard Breuer, and discussing will be Olga Takachi. Richard Breuer joined some introduction, joined the department for structural change and productivity in October 2015. His research focuses on innovation and productivity at firm level and as well on aggregate effects. Olga Takachi, PhD candidate in Dresden University of Technology, research fields in economics, science, and innovation, applied economics. Paper 8 will be the path to convergence, reallocation, responsiveness, and growth by Javier Miranda. Javier Miranda, current position is head of research group, entrepreneurship, innovation, and productivity growth, Hall Institute of Economic Research, deputy head of department within the same institute, and also professor at the Friedrich Schiller University, Jan. Discussant is Professor Eric Bertelsmann, professor at the School of Business and Economics Research Fellow, Tingenbern Institute. I call you on the panel, please.
Well, now it's my turn to figure out how the magic thing works. Let's just. Okay, great. Well, thank you for listening to what I have to say. So I retitled the paper slightly to Searching Where Ideas Are Harder to Find, the productivity growth slowdown as a result of firms hindering disruptive innovation. And let's just jump right in to define the research question a bit. So we have declining productivity growth across the developed world. And we also see that a lot of stuff's happening in the research patenting world. There's a couple of papers about how patents and scientific publications have become less disruptive, less scientific, less creative, using citation patterns and also textual analysis of patents. And there's also this famous point that researcher productivity for given tasks declines. So that's the whole searching where ideas are getting harder to find idea, right? So the idea that as we build on existing research, it's becoming harder and harder to contribute, and it takes longer and longer, and productivity declines of the researchers. But firms still hire more researchers, right? So expenditure for R&D is actually going up. So that seems to be weird. And there's a couple of different explanations out there. And what I'm trying to sell you today is not that these other guys are wrong. I'm just trying to sell you that there is an additional mechanism, right? So there's the paper by Olmsted Rumsey that actually tests a couple of hypotheses and in the end pins the fold on a decline in patent quality. There's the paper by Martin about the effect of ICT that can also lead to what we observe. And there's the paper by Akshin and Atis about how declining technology diffusion can also fit some parameters that we see aggregate in the real world. Yeah, so What I'm trying to sell you is the problem, or one of the problems is that disruptive innovation has declined and firms are doing more and more incremental stuff, and that's causing problems. So in order to convince you of that, first, let me gather some stylized facts about disruptive innovation and its cost from the patent data. Then let me build an endogenous growth model with disruptive and incremental innovation. And then I'll discuss a bit under which conditions innovation becomes more incremental in this model. And then we'll do some counterfactual simulations to see what we expect to happen in the real world if the model is correct. I'm gonna mostly skip, what the literature on the related papers are, because the papers, of course, related to endogenous growth, and that's we can summarize that for the whole duration of the talk. But just for those who are interested, so the closest model to what I'm proposing today is the one by Aksheed and Kerr, 2018. There's also a large literature on matching labor markets where people and firms meet and negotiate about the positions. And I've put a summarizing paper there as well. And of course, in principle, the idea that there are dynamic inefficiencies in innovation and that there are externalities in innovation is also not something that I think I need to convince you of, because all these other people have hopefully already done so. So let's go for the empirics. I'm using PatStat with some 70+ million international patent applications with an inventor name, country and address, and importantly, also with the citations between all these millions of patents. What the main measures that I get from this data is first the disambiguated inventor names. So as those of you who work with patent data might know, the data inventors are actually quite terrible because everybody just scribbles something in the inventor form, and then you are left to figure out whether this Richard Breuer who patented something in Munich is actually the same person than this other Richard Breuer in Halle, and whether Richard Brü is also the same person. So there's a lot, you can have lots of fun here. And in the end, I mostly apply the patents view algorithm from the USPTO that deals with these problems by looking at co-authors, technology fields, and basically then you do a huge machine learning exercise, and then it tells you which of all these different Richards are the same person and which ones are not. Of course, that's not without error, but it's the best that we can currently do. I also take the technology fields. So these are descriptions of what the invention is actually about, and 5-year citations. Right. So the idea here is that after 5 years, you have a pretty good idea of how good the paper is going to be. And of course, there will come in additional citations. But the advantage of stopping there is that you can compare the number of citations across years. So this is the data with the different patenting regions, right? So you can here see the number of patents in Western Europe, the former communist bloc, Japan, Korea and Taiwan, South Africa and the US. And you can see that the data starts somewhere in the 70s, depending on which region you're actually looking at. But the data that I actually use starts in 1980, just to be sure that there's no problems with, you don't have the citations or the coverage is too bad or something like this. So I wait a couple of years for the European Patent Office to have settled everything, and then I start in 1980. The measure of disruptiveness that I'm using is a derivation of what's done in the literature already. So we have here 3 patents, P, C, and O. P is the patent we're interested in. C is a citing patent, so a patent that cites P. And O is another patent that's also cited by P. And the measure is the citation year gap. So the difference in age between O, and P. Why? So the idea here is that if P is really revolutionary, then all the people that cite P should not cite old literature, right? So if this is, for example, CRISPR, the invention of CRISPR gene editing, then you would expect the people who use this technology to not cite all the old stuff about how you did it previously, but mainly, you know, literature that comes out of P. And the reason why I use this age is that it's a continuous variable, and that has, you know, nice properties if you are looking at small technology classes, whereas what the literature usually does is counting citations and then building some ratios and so on. But if you only have small groups of patents in small technologies, that can get pretty discrete in values and a little bit weird. So this is the decline of disruptiveness using this measure. And of course, so that's not new per se. All the other literature that I cited in the beginning also find this. So how to interpret this figure is in 1980, citing patents of patents cited other literature that was on average 1 year older than the original patent P, right? And in 2010, it's 4-point-something years. So we have become, in that sense, more incremental, that everybody is citing all the old stuff. There is an arrest in this decline in the 90s, and that's got a lot to do with the ICT revolution, right? There was also a productivity bump in the US in the 90s. And if you look at the patent classes that are most disruptive by this measure, a lot of them are related to semiconductors and software, ICT. Games, for example, is also a very disruptive class. Now, in order to understand what a disruptive innovation, a really big disruptive innovation does, I'm doing an event study within IPC class. And so I do nearest neighbor matching of the IPC class to another IPC class on my measure of disruptiveness of the past 4 years, on the number of citations, and also of the number of citations of established inventors. So what I mean by that is I look at all the inventors that entered the technology field 5 years before the time we're looking at, and I count all their citations up until today. This is the balancing test, right? So here we have before matching, of course, huge differences between disrupted and non-disrupted IPC classes. So you don't have to go through every number, but I mean, you see all the stars, right? And it makes, of course, a lot of sense. Disruptions are not random. And yeah, the classes differ a lot. After the balancing, the differences are no longer as large and almost always not significant. And you can also see that the numbers actually went down substantially, right? So now we are left with 1,631 disruption events that we will be looking at in this event study. 3 things I want to show you. One is the probability of a subsequent disruption. So we have the 2 IPC classes. Then in T0, the disruption happens. And then we look at the probability of further disruptions further down the line. And what you can see is if we compare the treated, so disrupted IPC classes to the untreated controls, there is this declining pattern where disruption births new disruption, but the effect decays over time. For citations, we see the opposite. After a disruption, citations increase in the IPC class that was disrupted. And for citations of established inventors, we again see the opposite. So if you are in an IPC class and then suddenly someone comes and invents the electric car, and you are an engineer that has worked, on tweaking, getting every little bit of efficiency out of the diesel engine, then it's not good for you. Your citations that you will receive over the rest of your life cycle, in a sense, go down by roughly a third. So now we take all this stuff. So disruptions birth additional disruptions. Disruptions hurt the inventors in the IPC class, and disruptions increase citations of overall of the IPC class, and we put them into an endogenous growth model. And just to give you a very high level overview, bird's eye, here we model technological progress as a function of the resistance to innovation, basically, right? So I completely abstract from the investment decision. The supply of inventors in this model is exogenously fixed. The only thing that I'm interested in is what type of research happens in equilibrium. The structure is each product is equivalent to a technology field, and each technology field is split into technology clusters that represent the different broader technologies, right? So we have the product car, it's linked to the technology field transportation or car manufacturing, or however you want to call it. And then within this field, we have different ways of how to get something moving, right? We have the internal combustion engine, we have the electrical engine, we have steam power if you are in the very beginning of the car world. And every time a disruption happens, the cluster changes. So the underlying technology fundamentally changes. And there's an exogenous number of inventors that enter the newest cluster every year. So every year the university system spits out new car engineers, and they become either internal combustion engineers or electrical engineers or whatever the current technology is. And there's also an exogenous amount of disruptive inventors that try to mess it up for everybody else and put the technology to the next level. So growth in this model looks like this. We are just stacking boxes that represent small incremental improvements on top of each other over time. Then a disruptive innovation happens. All the old inventors become obsolete, right? So now we are doing electric cars, and your skills with the internal combustion engine no longer matter. So innovation slows down for a bit in terms of the number of patents, because there's not many inventors left. And then it picks up again, but now the product improvements are bigger, right? And in order to get constant growth out of this model, you have to disrupt continuously every couple of years, but you also don't want to disrupt every year, because then you will never have incremental improvements, because all the inventors get obsolete so quickly, right? And you can see here, the gray line represents the steady state growth path in a sense. Looking at the time, so there's product markets in this model, surprisingly, and the firms that we are actually interested in are the intermediate producers that are monopolists for their specific product. And these firms optimize the value function, where basically their value comes from the stock of inventors they hold. So they go to a labor market, randomly matched with inventors. build a portfolio of inventors, and then the decisions they make have to maximize the value of that portfolio. And the key points here are every inventor gets you a stream of new patents. Every inventor exits with probability delta. There is a disruption risk, and this disruption risk is a function of, as we'll see in the next slide, of which firms try to hinder disruptive innovation. But from the viewpoint of you, the incremental firm, there is this disruption risk that threatens to destroy, your entire portfolio and basically set your value back to zero. Then you have to pay wages to the disruptive inventors that you are poaching. And over time, other firms also poach more, and that will also affect the value you have, right? So these are the 5 things you have to take care of. And I'm not going to force you through the optimization, of course, but we can look at how a sector in this economy behaves. So the total number of incremental inventors over time, and time is here measured since the last disruptive innovation, goes up, right? So new people come in from the university, the firm is higher, then everybody's happy, and the number of total inventor skill that's available in this technology field just goes up. And then at some point, some firms will have such a valuable portfolio of incremental inventors that they will start poaching. And that's what you can see here, right? So we have firm research quality on the y-axis, and this gives you sort of the poaching threshold or the share of non-poaching firms. And you can see at some point the value of the accumulated inventors is so much that the very best firms will start poaching. And then as you move forward in time, the value of the inventors that everybody has increases, and then the next firms will start poaching, and then the next firms will start poaching. And the longer the technology clusters survives, the larger the established firms will be, the more valuable they will be, and the more of them will start poaching on the market for disruptive inventors. And this will lead to sort of a vicious cycle, right? Because now, since all the disruptive inventors are getting poached and put into the incremental firms where they're basically drinking tea all day and not doing anything for the economy, the value of the incremental firms is going up because their risk is going down, right? Because nobody's doing disruptive innovation anymore. And so it becomes even more valuable to get the last few inventors out there. And we have this vicious cycle in the technology field, right? And that's the mechanism that I'm proposing. And with that, let me directly go to the counterfactual simulations here. So we can have a look at what effect it has when I change a parameter in the model, right? So for example, if we increase the value of making a disruptive innovation. In the paper, I call it the first mover advantage, right? So you get something if you're the one who is doing the disruptive innovation, because you're the first firm in the new technology cluster, that's valuable, and the parameter for that is gamma. If this increases, then more disruption happens. If the number of incremental inventors that the university system produces, H Inc., if that is increasing, then actually the rate of disruptive innovation goes down, right? Because now more incremental inventors are coming into the world, and the firms that get these incremental inventors will be more valuable, and they will have a high incentive to poach. And so in this model, producing incremental inventors is actually sort of a double-edged sword, right? So you don't want to produce only those, at least. And now the last step basically is to calibrate this economy to what we observe in the patent data in 1990. So I'm not going to go through all the parameters, but basically the idea here is, okay, I have this data of how the economy, or not the economy, how the European Patent Office's global patent data looked in 1990. I can see the age of the technology cluster, so I can see how long ago the last disruption happened. I can see the number of inventors and so on. And so I take all these parameters, plug them into model, and then simulate the economy forward. Hi. I'm not sure. Now it works again. Okay. And this will, so here you can see what the predicted evolution of the disruption rate, so the arrival rate of disruptive innovations, is in this economy. You can see that it's slowly gliding down. And this is exactly this vicious circle, right? So everybody is getting older, more established. The number of incremental inventors increases even further. This gives me even more incentives to poach, and so on. And yeah, this is what happens in the model as well. So just to wrap it up, we had an event study measuring in the data the effect of disruptive innovations on the IPC class. Then in the model, I include an inventor labor market into an endogenous growth model. And this allows firms to slow down each other's innovation, right? They can interfere with each other by poaching on this market. And it also creates the asset that the firms will actually protect with this poaching. Firms deliberately slow down innovation or aggregate innovation in a sense by poaching each other's inventors, even though it declines aggregate growth. And technological progress happens because firms refrain from doing that, or because the social planner intervenes and tries to stop them. And this aggregate aging effect that is very important in the model explains roughly half of the decline in disruptive innovations that we actually see in the data. Thank you.
I invite Olga Takachi discussing.
First of all, thank you very much for the opportunity to discuss this paper. And thank you to you, Richard, for the very wonderful paper. And I would like to suggest and recommend to everyone to go and read the paper. It's a really wonderfully written. And in the beginning, I would like to say that these comments are to for the paper and not for the presentation. And I would like to keep the comments a little bit shorter since we already had a discussion, and I can also send you the slides and the paper with my comments. So first of all, I'll very briefly summarize it because we already heard the paper, but the main aim is an endogenous growth model to analyze the difference between incremental and disruptive innovation activities. And you use the PATSTAT data for beginning with 1980s till 2010, and your key result is that 52% of the decline in the rate of disruptive innovation can be explained by incremental firms preventing the technology disruption through poaching of disruptive inventors. I have some highlights, I would like to call them, and also some disruptive contributions you made there. First of all, I would like to say everything was wonderful, but of course, some key highlights were that you indeed can follow the inventors in PATSTAT, and I also work with PATSTAT. I know that the data regarding the inventors is a mess, because every time there is a patent application, there is a new applicant ID. So you're doing a really nice job in following the inventors in PATSTAT. You come up with an event study within the data set, which is really interesting. And also you put that very well in a theoretical model and a policy relevant research. And now being not so
harsh in your definition of simplification of disruptiveness, because in my understanding, it is not a simplification, but it's actually a new definition of the patent disruptiveness measure. I have some major and some minor comments. I'll start with the introduction and stylized facts. First of all, in the introduction, I would have liked to hear more about your productivity measure. As I understood, you want to analyze the productivity of inventors that then sort or are poached by the firms, and then this reflects in the productivity of the firms, and this reflects in the productivity, general productivity. But it's not clear in the introduction, so I would recommend to include a very direct link from your data to your model and also to what you want to explain with the productivity measure. The second point is the figure number 1. I was wondering whether this is the figure we saw on the overview of the patents across different countries. Well, I was wondering how can we really compare it, because yes, it's not comparable to former communist bloc. You need to normalize the number of patents you plot on the epsilon on the axis, because then we compare an aggregate measure, and we see a rise in 90s for former communist bloc, which is not so really believable given the huge out migration from Soviet Union to other Western Western countries. So I also was wondering what information you are using for plotting by region. Is it the patent authority you are using? Since you are also interested in inventor data, is it the data, the country of origin of inventors? So this was not so clear in the paper. Then you extend in the text, or you mention in your text twice on page number 6 and 11 that you're providing this mechanisms to identify inventors and to follow the inventors in time. But you mentioned it twice, but never in a way that it's clear what you're doing. You, of course, provide an appendix, a very extended appendix. And for someone who is really interested in finding out how you're doing it, the person probably will go to appendix. But since sometimes it's a matter of time, you would like to find out in one sentence in the text, or recommend to write a sentence or to summarize in a paragraph how you implement this method of following the inventors in time. Then you use 50% as the threshold to define innovations disruptiveness. And I wasn't sure whether it's based on the literature, whether it's your recommendation. There is no citation or explanation for this measure. And then finally, you're using 8-digit IPCs, which are the subclasses within the patent data, but these are not technology classes. These are two different groups, and you should be very clear whether you're using subclasses or technology classes. Technology classes are based on the World Innovation WIPO 2008. I also provide a source to this. And you also should motivate why you choose the 8 digits IPC. I might know because this is the most detailed level, but you also do not get lost in the details in the two broad definitions. So, but it was missing, or at least, of course, this is very subjective, and at least for me, it was definitely not enough motivation behind this 8 digits IPC class. Some further comments regarding your event study result. I wasn't sure what matching you are using to provide your table number 1. You also presented today, summarizes the matching approaches, but what kind of matching? So you're using two matching. So you have to explain what are these results then in the table 1. I was wondering whether it's should we worry about the statistical significance in the difference between control and treatment of your number of citations to the technology class at time t. This might not be. We probably should not worry about this because it's time t and the citations are not so high in time t, or at least did not happen yet. But since it's the only coefficient that is highly statistical significant negative, so you have somehow to explain it or to give a short comment on that. Then you mentioned your paper matching mainly works for larger well-cited IPC classes, where isn't it biased in itself? I wasn't sure about this sentence. Maybe it's nothing to worry about, but you can also maybe reformulate it. Finally, I was wondering whether you could summarize, I think it's enough for appendix, the characteristics of these IPC classes that are the disruptive IPC classes. Can we somehow group them? Can we maybe just, I don't know, think of it as green technology classes? Are these ICT or etc.? Then going to the model, there are many comments, but I would like to concentrate on some of them. So first of all, I was wondering whether the characteristics of the field may also have an impact on the disruptiveness and also on the disruptiveness of the innovation by the inventors and how these are poached and then benched. Another idea was regarding the specialization of inventors. Where, for example, specialization may also not occur only within one firm, but maybe also firms are interested in these specialized inventors and will try to poach them. And also this relates to my third comment, under what condition an incremental inventor can also become a disruptive inventor within the firm. And how do you exclude this from your model? Because it might be very difficult to model this. But maybe there are some assumptions you can mention regarding this model. Then I was trying to come up with an example to explain your model in a very simple way. And thank God I watch enough movies. Since I remember the BlackBerry movie from, I think it's from this year. I was unfortunately too young to remember this era of BlackBerry's products that disrupted the mobile communication market. But then there was like this an interesting story about the time when when the market concurrence of BlackBerry, Apple's, and Android came and disrupted again the market and benched basically the BlackBerry. So, and BlackBerry tried. That's why the evil for the other person, because the one is the inventor, but the other one is the one who was trying to attract the Microsoft employees to work on the product, on the BlackBerry product. And actually, they did not, at least in the film and from the Wikipedia webpage, they did not try to bench them, but they actually tried to increase the productivity within the firm, within the BlackBerry firm. So, yeah, maybe this can also be something you could extend on in your policy, policy implication chapter. So finally, some minor comments. I will suggest to shorten your title, and I have a suggestion for you. Further, I would like to read the stylized facts again section, but I would recommend to write it in different chapters because it's quite long. And I do understand why you wrote the stylized facts, data, and event study in one chapter, because you first present the theoretical based stylized facts, and then from event study, the empirical based. However, it's very long, and it's yeah. Then you present the figure 4, which is I think also the one we saw today, but the interpretation is missing in the text. And also there are further comments. I will provide you with a paper. Finally, always when I read a paper, I try to keep the track of my excitement through the paper. So my excitement to read this paper was very high at the beginning. Then you lost me a little bit after the introduction and stylized fact, because it was very much information. I was trying to understand what's your scope, because there are a lot of you aim a lot of things in the paper, and this is wonderful, but maybe there is a need of restructuring and highlighting the major contributions of your paper. Then my excitement increased with reading the theoretical model because it was really wonderfully explained what we see in the data. You again lost me a little bit in policy implication because I thought it's a little bit too complicated. Like it's very complicated formulated in a very complicated way, and I would recommend, because policy implications section is always something probably everyone can relate to. So, and I would like to relate to this, and I would like to read it in a more easier way. And finally, now I'm very excited to read your paper again once published, and I really wish you good luck, and thank you again for the wonderful paper.
Thank you, Olga, for the very interesting observations. I take the feedback from Richard, and then we go to the questions.
I think we should collect all the questions maybe first, and then.
You prefer getting all questions, or okay? Any questions, please?
Hello. Okay. So yeah, great work, Richard. I really enjoyed it. I like it. I have a question. It's going to pick up on some of Olga's points, and it's your interpretation of the facts. And so the story that you're telling us is that there's these nefarious businesses that are plotting to prevent other businesses from innovating, and to keep the stock of their inventors and the value of their innovations. But there's an alternative interpretation linked to the burden of knowledge hypothesis, right? It gets harder and harder and harder to push the technological frontier forward, and so a natural extension of that is that it's going to take longer, right? You're going to require more and more inventors to push that forward. So that's in the literature. There's lots of work on that. So it's really more about interpretation. I hear you tell us a story, but there are alternative stories that fit the facts, as I understand it right now. And but why is this important? It's because the policy implications are very different from the types of stories that you can tell. And so just your thoughts on that.
Thank you. Any more questions?
So I didn't read the paper, of course, but I was wondering whether you can actually follow your inventors along their trajectories, maybe see whether they move from startups to large incumbents, and then maybe this could say something about the actual story you're telling about.
Yeah, so first of all, thanks a lot. I think it's a super interesting paper, but maybe some clarification also on this measure of disruptiveness. So basically, and then this may be my ignorance, so maybe you can explain, but if you look at the citations, do we actually know that it's the firms deliberately doing this, or is it like the patent organizations, the patent examiners? I think this is a bit in line with, how do you interpret this in the end? Maybe it's just indeed there is this huge blocks of knowledge that we just now build upon. It's more difficult to actually do this disruptive kind of innovation. So your views would be appreciated. Thank you.
Any more questions? No.
Thank you. Thank you for all the comments. Yeah, so let me maybe go in reverse order so that it's still fresh in our minds. So yeah, what causes citations? Is it the firms or the patent officers? Actually both. So the firm submits an initial list of citations, and then the patent officer, if he or she thinks, well, this should really be here, but it isn't, then they will add additional citations. I didn't use the difference of, who added them. And it's also, I think, not generally available in the data set. Regarding, so this, I would argue that this is mostly a problem of the very first figure where it shows the decline in disruptiveness over time, right? Because it could potentially, of course, be that the norms around patenting have just changed over time. But I think the way I address that in a paper is basically by the event study where I match IPC classes of the same age against each other. And then you really see, after a disruption, both of these IPC classes like start in the year, let's say 1995, and then we see the trajectory going forward of both of them. So if there are general patenting norms or citation norms that have changed, we should see it for both the disrupted and the not disruptive group, and it should, in the event study, wash out. That would be my answer to that. Then also the question of whether we can see inventors moving to established firms. So you can generally see that in the patent data, and there is actually also already a paper on that finds exactly this effect, that successful inventors that move from startups to established firms decline in productivity. So this is very like in line with what the model would indicate. So then the burden of knowledge versus disruption. So I think mainly the event study tries to defend against this criticism in a sense, right? So here we have, again, this comparison of disruptive and non-disruptive classes. And if this disruption story didn't work, then we shouldn't see the differences for the established inventors. We shouldn't see the citations mainly going up for the disruptive class. So I think this indicates that disruptions increase future productivity of research and hurt, the established inventors. And that works a little bit against this, that it's just the burden of knowledge or searching, finding ideas getting harder and harder. However, I would say that actually in this model, there is this effect, right? So within every technology cluster, the longer you don't have an innovation, the model actually predicts exactly the same thing as this, for example, the Van Reenen paper on observers actually on specific tasks, right? So that's one of the papers that argues very forcefully for the burden of knowledge channel. And what they do is they have the productivity of research in specific tasks, like, doubling the number of transistors on a chip, or increasing the yield of an acre of land and this type of stuff. And basically, both my model and sort of their way of thinking about it predict that if you just continue doing what you're doing and you're just trying to get better and better at one specific task and you're not disrupting, then you have this burden of knowledge and you will run in a way, just against the door repeatedly, and you will make very little progress after some time. And the argument is that you need these occasional disruptions that spin you into a completely new direction, but that within each specific task, in a sense, there is burden of knowledge also in this model. And also, of course, thanks a lot for the discussion. Let me maybe react to, or I don't know how much time. Yeah, we have some time left, right? Not really? Okay, so then let's maybe discuss afterwards.
I now invite paper 8, Javier Miranda.
Well, thank you so much. Thank you for the organizers to
including this paper in the conference. This is a small little paper. This is a work that I'm doing for the World Bank. Ufuk is leading the World Development Report there for this year, and so this comes out of a collaboration with the World Bank. What are we doing here? It's an age-old question. It's the path to convergence, and we're going to be looking at reallocation, responsiveness, and growth. Let me make sure that I know how to work this. Yes. So, so I don't think I need to motivate this a lot. We had a panel yesterday, a policy panel that talked about the divergence between the US and Europe, laggards and countries that are at the technology frontier. And so, of course, business dynamism is important. We know this is critical. Reallocation of resources leads to productivity growth. It's a significant contribution to productivity growth in our economies. And of course, Schumpeterian growth models are going to emphasize the role of innovators, technological diffusion, and of course, countries can converge in adopting technologies that are in the market. But of course, it's going to be key to have the appropriate institutions in place that set the conditions that allow for innovation, and importantly, for the reallocation of resources across firms and to their more productive uses, right? So businesses that are not innovative, they're not productive, we should see as a result of market forces a reallocation of those workers towards activities that are more productive, right? And towards firms that are more innovative. So appropriate institutions is key and are key also in these types of models. What are we going to do? We're going to use harmonized microdata from 19 European economies at different stages of development to explore business dynamism and convergence, right? We're going to be focusing on a set of moments, very specific moments. We're going to be looking at reallocation. We're going to be looking at productivity patterns. And then we're going to exploit the microdata to look at and explore how firms respond to their environment in the different economies that we have in this data. So what are the questions that we're going to be trying to address? This is early work, I'm going to say. So can we use this microdata? We're going to be using the CompNet data, not the MDI, although we introduced a little module to generate some of the moments that are not in the CompNet data. Okay, so can we use this microdata in a cross-country setting to explore the connection between reallocation, business dynamism, and growth? The answer to that question is going to be yes. And we're going to be following on a long literature that has been using these types of moments for this. So do we find evidence of convergence in Europe across these different economies? The answer is going to be yes. We're going to find that knowledge diffusion and the ability to take advantage of opportunities is going to be important. But we're going to find large variation across countries in that ability to take advantage of the opportunities. So framework conditions are going to matter. The paper doesn't today include any analysis of framework conditions. I'm working on that. I have some results. I'm not going to show you those results because I'm going to run out of time. But that's kind of where we're heading. Just a little bit more on the theory. So Schumpeterian growth models, innovation, entrepreneurship are key. Creative destruction associated with that innovation is what's going to lead to productivity growth and the growth in our economies. Of course, countries that are further from the technological frontier have the ability to attract and adopt existing technologies. That's knowledge diffusion. So what are some of the predictions? Faster innovation-led growth. The more innovation there is in an economy, that's going to be associated with more reallocation. Right? So we just heard about disruptive innovations. innovations in general should lead to reallocation of resources towards businesses that are more productive and gain in productivity from an innovation shock. Importantly, for the convergence story, countries that are further from the frontier can, of course, leap forward by adopting existing technologies, right? And so there is the advantage of backwardness. The further away you are from the technology frontier, of course, you can, as you adopt technologies that are in the marketplace, you can leap forward and catch up potentially very quickly. And again, of course, frictions and institutional failures will lead to lower productivity reallocation, enhancing reallocation, and economic growth. So it can lead to less innovation, less adoption, but importantly, even when there is adoption, if companies are not able to take advantage of these opportunities because of those frictions, for example, in labor markets, it's going to lead to lower reallocation and productivity growth. Okay, so the empirical evidence is a long literature. I'm not doing it any justice here. I'm not even trying to make it justice. I'll just mention Eric's AR paper from a few years ago, looking at reallocation and growth. There's papers on allocation and growth. I'll mention the Reader's AR paper on the importance of intangibles, and I'll mention my own work with Halte Wanger and Jarmin and others, and Ryan, focusing on adjustment costs. So lots of evidence that these things matter for reallocation and for growth. So I'm going to be testing two hypotheses. The first one is that reallocation is inversely related to the level of development of a country as measured by its GDP per capita, right? And so if you look at the chart on your left, countries that are further from the technological frontier should have the ability to introduce innovations rapidly, and there should be more opportunity for reallocation as a result of incorporating those innovations. A related hypothesis is that higher reallocation countries are going to experience higher GDP per capita growth. Okay, so the further you are from the technological frontier, the faster you can leap forward towards that frontier. The more reallocation there is, the higher GDP per capita growth we should observe. So we're going to be testing that hypothesis. The second hypothesis is related to framework conditions. So conditional on your level of development as captured by GDP per capita growth. So conditional on that, the higher your level of reallocation, perhaps because of the framework conditions that are prevalent in the country, the faster is going to be your convergence. So you can see that in the second chart. So we're going to be doing some simple analysis to test this hypothesis. Just a little bit of preview of findings. So we do find indeed that reallocation is higher in less developed economies, consistent with this idea that there's more opportunity for productivity enhancing reallocation from the adoption of innovations. We're also going to find a positive correlation between reallocation rates and GDP per capita growth. Again, consistent with productivity enhancing reallocation. So we are going to find, in general, a path to convergence in Europe. We're also going to find that countries that experience reallocation rates in excess of what is expected by their level of development, technological position, are going to be experiencing higher GDP per capita growth. Okay? So framework conditions, local conditions are going to matter, and they're going to matter a lot. Again, we're going to be looking at the microdata, and we're going to find the evidence of difference in knowledge diffusion across economies. Importantly, we're going to find differences in the ability of economies to take advantage of those opportunities. Okay, so we're going to see that in some economies, businesses are not going to be as responsive to their productivity innovations as in other economies. So lots of variation in reallocation and responsiveness across economies. So country-specific factors, again, are going to be very important. I won't have to show you time to show you results for labor market institutions and how that matters in this regard. A little bit about the data. This is CompNet data. The only thing that I want to say here is this data is accessible to everybody. You can send us an email to the CompNet network, and you can get access to all of the data. It's not data that is easy to use. There's training modules. You can visualize the data before you even touch it. So there's all kinds of things that you can do, and so very, very, very accessible. There is some investment that you have to put into it to just get to know the data a little bit, but the trainings are great. So what's the basic moment that I'm going to be looking at? Is a standard measure of job reallocation. We're going to be using measures that are standard in the literature, Davis Halti-Wang-Verschuur metrics. How should you think about it? Just think about it as a measure of business dynamism. It's the sum of all jobs that are created or destroyed in any given year, in a given economy, or in a sector, or in a set of firms with given characteristics. Okay, so it's a measure of the business dynamism, the reallocation of resources that is taking place in an economy. Okay, so we're going to be comparing reallocation rates across economies, and we want to abstract away from some basic compositional differences in terms of sectoral composition. Some sectors are just more volatile than others, and so we want to abstract from that. So we're going to compute an adjusted measure of job reallocation. We also want to abstract away from country-specific shocks that an economy might be experiencing. So we're going to abstract away from that as well. So we're going to compute an adjusted measure of job reallocation. Here, the beta 1, if you will, that is country-specific. And it's going to be a measure that it's a weighted average of data for seven years, 2010 to 2017. Okay? So again, we're going to be looking at this adjusted measure. Here you can see how job reallocation rates and this adjusted measure compares. Of course, they're highly correlated, but you can see that there's quite a bit of variation across these economies. I think something that I want to highlight for you here is that some economies like Spain have very low reallocation rates, but once you adjust for composition, they actually have even lower reallocation rates. By contrast, Germany, that does have also low reallocation rates, once you adjust for compositional differences, actually have higher reallocation rates. Once you make those adjustments. The other thing to note here is Eastern European economies in general have higher reallocation rates. Reallocation rates here range anywhere between 15% and 22%. Once you think about adjusted rates, they go higher. How to interpret this? If you look at the 15%, it's like 15% of jobs in this economy are either created or destroyed in any given year, right? So there's lots of reallocation taking place in these economies. Okay, so to the first hypothesis, do we find that reallocation is inversely related to the level of development of a country as captured by their GDP per capita? And they're related, do we find that countries that have higher reallocation rates experience higher GDP per capita growth? Okay, so to the first one, to the first question, indeed, we do find that there's an inverse relationship. So countries that are further away from the technological frontier, as captured by the GDP per capita growth, have low GDP per capita growth. experience a lot more reallocation, right? Consistent again with this idea that there's lots of opportunities for productivity enhancing reallocation from the adoption of innovations broadly. Okay, so here I also want to point out for you that Eastern European countries are here on the right, have higher reallocation rates and low GDP per capita. Western economies, Western European economies are of course on the other side, but notice that for Western Europe, this relationship breaks down a little bit, in particular for some of the Nordic countries. Okay. So what about reallocation and growth? Do we find that higher reallocation rates lead to higher GDP per capita growth? And indeed, we find that is the case. There's a correlation that you can see. And so what you see in this picture is that European countries that have a low mean income tend to be on the top right of the chart. The richer economies, the economies that are closer to the technological frontier, are in the bottom left corner. So a lot less reallocation in countries that are closer to the technology frontier and less GDP per capita growth, okay, consistent with the convergence hypothesis. Okay, so what about the second one? So here we're looking at, do framework conditions matter? What happens thank you. What happens when you condition on your level of development as captured by GDP per capita growth? So again, what we expect to see is that conditional on your technological development level, countries that experience higher reallocation, again, perhaps because of their framework conditions, are going to experience higher growth and GDP per capita growth. We're going to have to create a measure of excess reallocation, and that's going to be very simple. It's a measure of excess reallocation from what it would be predicted or is predicted by your level of development. Just to note a few things here. Countries with negative excess reallocation that stand out: Spain, Portugal, Italy, and France. All right. So do we find that excess reallocations matters for per capita growth? And so here on the right side of this chart, you see countries that have reallocation rates that are in excess of what would be expected by their level of development, how far they are from the technological frontier. On the left are countries that exhibit reallocation rates below what would be expected by their position, their level of development. So what do I want to highlight for you here? Countries like Spain, like France, like Portugal, and Italy have reallocation rates much below what it would be expected by their level of development. Countries in Eastern Europe have excess reallocation rates that are higher and do experience indeed significant growth. I want to point for you the blue bubble on the bottom right corner. These are Nordic countries as well as Switzerland, and there there's a little bit of an anomaly where these are economies that appear to exhibit high excess reallocation rates, but no returns from that in terms of GDP per capita growth. I think I'm running very quickly out of time. Let me just check my time. I think I have 6 minutes. And so we wanted to dig a little bit more into the and try to understand the link between reallocation and growth. And so here we pulled from the microdata. And the first thing that we're going to be exploring are the the properties of the innovation shocks in these different countries. And so we're looking at measures of TFPR dispersion. These are going to be innovation shocks. And what I'm highlighting for you here in the left chart is that dispersion of TFPR innovations in Eastern economies is higher than that dispersion shocks in Western economies. Again, consistent with this idea that there's more room for productivity enhancing reallocation from innovations. But note, by the way, that these differences are not very high, and there's lots of variation also across economies that I'm not showing you. On the middle panel, you see that shock dispersion, innovation shocks in model terms are related to reallocation rates, and on the right panel, rightmost panel, you can see that indeed it is also related to GDP per capita growth. But there's huge variation across countries, right? These things are not very tight at all. Right? And so here we're going to be looking at how businesses respond to those innovation shocks, and whether they're taking advantage of those opportunities, right? Do firms that experience positive innovation shocks grow? Those that experience negative innovation shocks, do they decline? And you can see that the pass-through from the innovation shock to job reallocation differs dramatically across these economies. In general, responsiveness to their environment is higher in Eastern European economies, but there's lots of variation. Responsiveness in Western European economies is in general more muted, but again, lots of variation. So just taking stock in the last few minutes that I have, this is a very simple paper. We wanted to explore some of the moments that are available in the CompNet data. And we set out to explore the path convergence hypothesis kind of within the framework of a Schumpeterian growth model. The main findings: reallocation is higher in less developed economies, indeed consistent with knowledge diffusion and path convergence. We find a positive correlation between reallocation rates and GDP per capita growth, of course, consistent with productivity enhanced reallocation. Of course, countries that experience excess reallocation or reallocation in excess of what might be expected by their level of development do experience higher growth. So framework conditions do matter. And then, productivity shock dispersion is higher in less developed economies, and consistent with endogenous growth theory. And but again, huge variation across countries in the ability of businesses to take advantage of those opportunities and those innovation shocks. So so all to say, we all care about growth. We care about convergence. We care about understanding the conditions that lead to growth. Of course, we had an amazing panel yesterday. Again, I'll say it again, that discussed some of those framework conditions. But it is, I guess, what I want to leave you with is that there are huge differences across countries in their ability to take advantage of innovations, to diffuse innovations through the economy, which ultimately is going to have very important implications for their path convergence and their ability to grow. So paying attention to those framework conditions is particularly important. I'm going to say here we're talking about job reallocation. And so from my previous work, but also here, I'm going to emphasize adjustment cost, right, when it comes to reallocation of resources across businesses. And so I'm going to stop here. Thank you very much for your attention, and look forward to your questions.
Thank you very much. I'll invite Eric.
All right. Again, it's my pleasure to be here and really fun to discuss a paper of hobbies. I'm just be nice because we have to work together for the next few months. For years. So I'm not going to do any hardball discussion type stuff today. So before, yeah, be forewarned. It's going to just be softballs. You know, this paper rings a bell. Kind of this literature was interesting. And as I was diving accidentally into some archives, other button. So let me just start with some general remarks. I think one is CompNet is delivered. So this type of work shows that the moments that are available let you delve deeper into mechanisms underlying macro outcomes. And it's not just that you have industry data, but it's that you can go within the industries and try to get at micro mechanisms. And you know, job reallocation, productivity, reallocation rates, firm entry and exit. There's all kinds of metrics that have been developed, and these data sets have this stuff. So in the earliest years, you know, there was a bunch of hobbyists doing this, and now we have an institutional embedded facility to release regular updates and improvements and an expanding set of indicators from an expanding set of countries. I mean, it's just ballooned in 5 to 10 years. The cross-country analysis, that's the powerful thing, that you can use the variation across countries in framework conditions and policies, and then not just look, well, we know does lowering employment protection increase GDP growth, but you can get at the mechanism, what's going on underneath in labor markets, in output markets. So there's now high quality data, and I'd say also, compared to a long time ago, there's a large base of Schumpeterian firm level models that allow you to draw policy conclusions from basically simple charts and graphs. Simple slices of data. Now, again, I say simple. I realize for someone new who's downloading the CompNet database, it seems everything but simple. We hope to improve the teaching people how to do this properly. But we've seen examples now of stuff that you can do. So I really like that feature of this paper. So here's something that I found from 2002. And the dispersion in firm output growth rates, I think it was actually a sum of gross, a sum of gross market share changes across firms in an industry on the horizontal axis, and on the vertical axis, output per cap per. Anyway, and I couldn't even find the definition of the dots, but I think they're countries and quartiles. But I just found this graph somewhere. I do remember from this graph what it is that the referee said. And the referee said, I got a bunch of data points at the bottom, and I got a thin little string that they're hanging from. What am I supposed to tell about this? Okay, so they were pretty brutal. And of course, there were no models. So what do we have now? I'd say the evidence presented today is in the spirit of these earlier results, but it's based on robust data. You don't have to question every single data point or throw out the 3 that don't make sense, because they're documented and we understand what's going on. A much longer time period and many more countries. But also the storyline is much more than a vague hunch supported by a bunch of data points dangling from a string. In this case, we have 2 very precise hypotheses, and underlying those hypotheses are well-developed Schumpeterian firm-level models of innovation, of growth, of reallocation. And so I would say these results, nowadays should be convincing for policy use. And I'll get into, almost be convincing enough for policy use if you hone down on what policies and you can distinguish. So we'll get to that. So, a bunch of data points dangling from a string. Okay. And then this one, is similar to what I was doing. And now one slice and dice you've done is you've gone from this, backwards. You've gone from this one and made your predicted growth and took in the deviations on the horizontal to get the excess reallocation. And then that really cleans up this graph. So that's a nice trick. So questions about policymakers and questions about convincing academics. I'd say that convincing academics, the narrative has to be supported by the data, but it's also need to be linked to a theoretical model, which really, you know, this theory is all complex math, but it's really just a story, right? So a good model is really just a coherent story, but that story has testable implications in the data, and that's what the power is of bringing, you know, the Actuated et al. And de Ritter type models to these datas, is that you can really learn, does this story make sense given my data? And when you have complex data sets with complex stories, you really need to slice and dice to understand what it is that's happening. So, you know, when I'm looking at this, and I kind of skimmed through the draft for the World Bank piece, you know, there's different causes of reallocation. So one cause is the mature economy, experimentation and disruption from new technology and firm entry. It's the stuff at the frontier that's kind of the original Schumpeter. But then there's this whole development literature where to get up the front, you would need existing firms to do the catch up. And so there's two different stories going on here. And the interesting thing, I think, are the boundary cases. So is Portugal a developed country that's at the frontier, but that's just doing it poorly? Or is it a country that's still in the catch-up phase? And what I really would like to know is, are the policies for the two different sets of countries different? And I don't know what, you know, what do you tell Portugal? Be more like Finland and Sweden. I don't know if Finland and Sweden are good examples, but more like the countries with high reallocation, really at the frontier, innovating like crazy. Should they be more like them? Or are they still in the period of trying to catch up to that group? And you know, I think that boundary is the one that would be interesting for policymakers, is to try to understand. And to get there, I do think, even though I like the story and I think it's convincing overall, to hone it in on which policies and why, you will need to develop a model that has these two processes in it, and that demarcates somehow when is a firm at the boundary of them, and does the policy change across boundaries? Because I think that's the interesting. So let me leave it at that. Oh, and I didn't discuss your responsiveness because I thought it was too close to the other paper that I already. Yeah.
Go for it. Any questions? Okay. Martin first.
Thanks a lot. It's a fantastic paper, and it's great to see how insightful this data is going to be. I have a very unfair question to you, which is, can we get more data? So here is the question. So the way that we measure reallocation, both in this data set and as well as in the business dynamic statistics, is not really a measure of labor market churn. Right? It's a measure of firm growth, because what you're adding up is the employment growth by the firms that grow and the employment shrinkage by the firms that shrink. So if you're in a world where no firm is growing, but everyone changes from one firm to the other, so you have 100% churn, your reallocation rate is going to be 0. And I think for technology diffusion, labor market churn is actually very important, because so much of knowledge is embodied in the employees of a firm. So obviously this is hard to measure because you require linked firm employee data, but should it be an ambition for us in the next couple of years, the next 10 years, to measure reallocation rates through actual labor market churn?
Lawrence?
Really, I enjoyed the paper very much, but I was wondering, what are the framework conditions that really are conducive for rapid growth? Those, I mean, that's
for sure.
Gianmarco?
Yes, thanks a lot, Javier, for the presentation. I think it's a really great paper. I mean, I noticed that during the presentation, basically, you did not claim causality, but still, from a policy perspective, it's interesting to draw some policy conclusion about this. So in terms of the causal link between GDP growth and reallocation, I was wondering, would your correlation survive, for example, if you made it conditional to some institutional quality measure? Because I was thinking that maybe the countries that grow the least and that with the lowest degree of reallocation are also the countries with the lowest quality of institutions that might influence both. And on the other hand, I was thinking that might there be some kind of reverse causality in this regard? For example, the countries that grow the least are the ones where the unions are stronger about labor rights, this kind of stuff, because the pie is not growing. So you try to preserve existing job positions. I was wondering if you thought about these and how they enter in your framework.
Yeah, for sure.
Would you like to react now and maybe?
Sure. I think Richard. Okay. Then I'll respond, and then Richard, we can talk later. So Martin, absolutely. So I think that I'm so happy to be collaborating with Eric. I've known Eric for 20 years. He sent me a little bit of code when I was at the U.S. Census Bureau. So he was doing his distributed model to get moments out of the data, and I worked through that code, that SAS code, a long time ago. So we've been making lots of progress, and I think you're absolutely right that the next obvious thing to link into this data are the linked employee data, is the worker level data. This is a huge amount of work, 20 years worth of work from lots of different people. But you're absolutely right. The thing is, this work never ends, right? We ask questions, we get some moments, it just generates more questions, and then we're going to need more data to answer those questions. So this work never actually ends. But that's a natural progression of this infrastructure that we're building. Absolutely. So the framework conditions, absolutely. So this is where this work is heading. So what are the type of framework conditions that we're thinking about? All of the things that people were discussing yesterday, right? And there's lots of metrics and indicators that institutions are putting together, the OECD, the World Bank, the IBR. There's lots and lots of indicators. Where are some of those things? Again, finance, innovation, R&D metrics. I very much agree with Eric that we need to think a little bit more about innovations and R&D when we think about these things. Labor market institutions, I think, are key to this whole story, and so of course those things are things that I emphasize and I expect to be working on. Gianmarco, you mentioned the quality of the institutions. There's metrics that capture quality of institutions, and so I had another slide that mentioned all of these things. And there are data sets that we can just bring. There's other moments for these types of that describe this type of framework conditions to bring into this data. So absolutely, we need to be controlling for some of these things. This is it's a very short paper. It's a very simple paper. It's a first approach, but that's kind of where we're going. And I think I'll stop there. I thank you, Eric, very, very much for your kind words, and happy to be collaborating with you and working together in the next few years. So thank you, and thank you very much to everybody.
And so this is sort of a broader question, but it's...
Sorry, I thought I was done.
So do you think that the single market is helping in this type of reallocations? So clearly this is the national perspective with the workers that are reallocating within boundaries.
Yeah, this is a really interesting question. And of course, we're just looking at Europe, countries that are fairly kind of within the same framework, if you will, right? Same culture, and within the European Union to a large degree. So does this matter? So I suspect it does, right? But I don't. But I don't know. So Martin mentioned data and expanding this data, and one of the efforts, and I didn't see Filippo. Haven't seen him for a while, but one of the efforts here is he's everywhere. One of the efforts here, of course, is to extend CompNet to other parts of the world and regions of the world. So there are efforts to bring and to build CompNet like metrics for Asia, for South America. And so with that, you hope to be able to answer those type of questions a little bit better. So I don't have a good answer to your question, other than let's bring more data to try to answer that.
Have you? I don't know whether you reacted to Gianmarco question. Yes. Yes, please.
Now, coming back on the additional data question, I was wondering whether it's possible to think at data on entry and exit through the MDI, for example, because clearly that is a key component of the US adjustment. No, I mean what Ufuk and coders find is that we all know. I mean, there's this prevention of entering of firms into very competitive industries from the big giants that is affecting the ability of the US to grow in productivity, among other things. So clearly here you just have no entry and exit dynamics properly measured. So I'm wondering to what extent you think this is going to be possible / contributing to your analysis.
Yeah, no, thank you for the question. It's an important question. So CompNet, because of data limitations and data differences across country, has two flavors of data sets. One incorporates firms only that are 20 employees or larger, and a flavor with a smaller set of countries that has more representative populations. And so I think that's an important way to push a little bit on that. But that's also the strength of the MDI, right? So there are things that we're not going to be able to do with the CompNet data. And so one of the posters with Leo in Dracolo, so that paper gets into the MDI, into the microdata, and thinks about some of these things a little bit more. So there are, you're absolutely right, there are things that we can do with the aggregate data sets that are easy to use, if you will. And then for some things, you're going to have to go. So I'm repeating things that people have already said. But yeah, absolutely.
I don't know whether any more questions. If not, I think we can wrap up. Thank you very much.
Thank you very much. Okay, everybody, let's start getting settled so we can start our last session of the conference. All right. All right, let's get started. Okay, so last but not least, we have Martin from the London School of Economics. He's going to present his paper. Richard from IBH will be discussing. That will be followed by Guido at the OECD with discussion from Bart Gorens from KU Leuven. So Martin, I'll give you 25 minutes. I'll give you clues. The floor is all yours.
Thank you, and thanks a lot to the organizers for putting us on the program, of course, and a big thanks for you all for staying, because Malta is so nice, right? Everyone wants to be on the beach right now, so I really appreciate it. So this paper is about green growth, and by green growth, we mean that there's a hope that over the next decades, we're going to come up with ways of producing our current levels of consumption and then some in ways that are less polluting to the environment. Now, our progress towards that is going to require innovation. Right? And the way that we measure innovation, measure progress, is typically through patents. Right? They're not the perfect measure of innovation, but they're probably the most direct measure of the output of innovation that we have at our disposal. So if you want to measure our progress towards green growth, one thing we can look at is what share of all innovation actually has something to do with green technology. And then we get this plot. So this plot here, the horizontal axis is years, right? It's 1980 to 2019 or 18, sorry. The vertical axis, you have the share of all patents that is related to climate change mitigation, very broadly defined. Now, the OECD has gone line by line through the IPC codes and has classified IPC codes as green or non-green based on whether they fit into particular characteristics. So a green patent, for example, would include technology related to LED lighting. It includes technology related to the batteries of electric vehicles. It also includes things like nuclear energy, which for the Germans in the room might be controversial, but for the rest of the world, we think of nuclear energy as green. And so what you see in this graph is that between 1990 and 2010, there's a rapid increase in the fraction of all innovations that's green. But then something changes, right? After 2010, 2011, you see that this growth in green patenting halts. And that's few years after the biggest financial crisis that we've seen since the 1930s. Right? So the question that we ask in this paper is it the case that green technology, green innovation, or new technologies more broadly are particularly sensitive to financial constraints? And what I'm going to present to you today is a framework in which green innovation is going to be more sensitive to financial shocks than non-green innovation, in a framework where there is no intrinsic difference in the ability of firms to finance green innovation and non-green innovation. Okay? Now, where does the magic happen? It all comes from two assumptions. Assumption one is going to be that young firms are more financially constrained than old firms. I don't think that's a controversial assumption, right? The second assumption is that innovation is directed in the sense that firms choose how much to invest in green R&D versus non-green R&D. And there are some path dependence in that. So a firm that has a track record of successful innovation in polluting technologies is going to tend to innovate in that in the future as well. Whereas a firm that has a track record of green innovation is more likely to invest in green innovation. Now, these two assumptions together are going to deliver what we see in the data. They're going to give together that if there is a financial shock, it's going to hit green innovation more strongly. Why is that? That's because we are on a transition. We're transitioning from a steady state in which there was a lot of pollution to a greener steady state. And on that transition, in the early stages of the transition, young firms are going to be responsible for a large share of green R&D. And that's because if you start from a world in the 1980s or the 1990s, where we didn't care yet about climate change, right? A lot of the incumbents are going to have track records of dirty innovation. So early in the transition, a disproportionate share of the green R&D is going to be done by young firms, right? Young firms are going to self-select into green innovation. And then because of the identity of the firms that are responsible for the transition in the early stages, you're going to get that when a financial crisis hits in a transition, in the early stages of a transition, there's going to be a bigger negative effect of the financial crisis on green innovation than non-green innovation, purely coming from the fact that young firms are leading the transition. That's the story, right? Eric said it earlier. Theories are stories, but we do have evidence to back things up. Now, I can't claim any CompNet credits on this one. So we're going to use German microdata to validate the mechanism. We're actually going to use a small sample of German firms. We're going to provide some causal evidence. So that's going to be my savior, hopefully, for this audience. And we're currently replicating the results for France as well, but I'll get to the evidence later. We then structurally estimate a Schubertian growth model, and we showed that up to 47% of this slowdown of green innovation might be a consequence of tight credit during the global financial crisis. And this paper offers a more general lesson for when financial crises are costly, because the mechanism that we have in our model just relies on young firms being financially constrained and there being path dependence and innovation. And that can apply to different technologies as well. Right? So whenever the economy is transitioning to a new technology, young firms are going to be responsible for the transition in the early stages. So financial crises that happen early in technological transitions are more costly than financial crises that happen in a steady state. That's the paper. I'm going to skip the literature and I'll move to what we do. Right, so it's model, empirics, and quantitative analysis. So the model is as follows. It's going to be a very simple model on the household side. It's a Clatter-Korte model for those of you that do Schumpeterian growth. So on the household side, we assume that the household derives large utility from consumption. It supplies its labor inelastically. It works all the time. It's like an assistant professor in, or like a PhD student in economics. Right? They always work. There's a continuum of firms indexed by J, and firms which are indexed by I produce one or multiple of the goods in the economy. Now, firms can produce any good in this economy, either with a clean technology or with a dirty technology. And those two are going to differ in the externality that they have on utility through pollution. Now, firms can produce any product in the model that they own a patent for. And a patent gives a particular firm I the ability to produce a random good J at some level of quality Qij. And that technology is going to be specific to either green or dirty production. So if you've invested in green R&D, you get a patent to produce with the green technology, and that then enables you to produce that particular product in the economy in a non-polluting way, in a green way. So what is quality? So quality determines bang for buck. It determines how much utility the household gets to derive from a single unit of output of your goods. So GDP in this economy is given by that big ugly equation there. So the outer integral here there has J, right? So J is are the products, and in the integral we have total output of product J, and total output is just the sum of output by all firms that can produce good J, either with the clean or the dirty technology. And you can see the Q in there, right? So output is multiplied by Q. Output Y is just the number of units that you sell. And so if you have a high quality version of a good, you produce in a way that gives more utility to the household. Firms in the market in the model are assumed to compete à la Bertrand. So that means that even though there might be multiple firms that can produce good J, there's only going to be a single firm that produces every good in equilibrium. Now, this is all standard. So those of you that have done Schumpeterian growth, this is really, really boring. So let me get to where climate change is going to come in this model. Right? So there's two ways to produce a good. Whether you get to produce with the dirty or the clean way, that depends on your production technology. If you produce with a clean technology, your only input into production is going to be labor. And that's what the first equation shows here. So we have output equals labor, where the C superscript stands for clean, for clean production. Dirty production, on the other hand, involves two inputs. It has the labor input, that's the LD in that equation, and it has some other polluting inputs, which we're going to call O for oil. It's a Cobb-Douglas production function, which means that you can just write the optimal amount of the polluting input that you use into production as a function of how much labor you use. So that's what you see on the right-hand side. So you see that the optimal amount of the polluting input depends on the relative output elasticities of oil, the polluting input, and labor, and the relative price of the two. So PO there, that's the price of a unit of this polluting input. So we can insert that back in the production function. What you get is that dirty production is equal to dirty labor multiplied by this term, right? And this term, the term in front there, that gives you the relative production efficiency of dirty versus clean production. So I'm going to call that term the inverse of P tilde. It's very convenient because it means that the marginal cost of producing a good in our economy with a clean technology is just a wage, because you need to hire one person per unit that you sell. And the marginal cost of producing with the dirty technology is going to be the wage times this P tilde. So P tilde is going to be the relative cost of producing dirty or clean. Now P tilde later on, when we implement taxes into the model, that's how we're going to embed policy. So over time, P tilde is going to increase, for example, because of a carbon tax. And so that's going to make producing with the dirty technology relatively more expensive over time, right? So we're going to think of P tilde as a policy parameter. So how do firms add products to their portfolio? They add products to their portfolio through innovation, and innovation is directed in the sense that firms choose how much to invest in green innovation as well as into dirty innovation separately. And how that works is given by the first equation, or the only equation on this slide. So that equation there gives the arrival rate of patents that are clean or dirty. So the H is either C for clean or D for dirty. That's the arrival rate of patents. And on the right-hand side of the equation, we have R&D, that's RD, that's the number of people that I hire. So the more people I hire to invest in clean innovation, the more clean innovation you get, the more innovation, the more researchers I hire into polluting innovation, the more dirty patents I get. But the important bit, and this is the key assumption that I talked about earlier, is that your R&D productivity, so how effective your R&D is, depends on your track record. If you have a history of successful R&D in a particular direction, you become better at that R&D. And that's the final term of the equation. So you have the N there, the NH, that's your number of clean or your number of dirty products that you already produce. So a firm that has a track record of dirty innovation, but it has a high ND in that equation, that means for a given number of researchers, there's going to be a greater number of new patents that you produce, right? So a firm that has a track record in dirty innovation is going to have a higher rate of dirty patenting for a given amount of spending on R&D. Now, we usually assume something like this. So we usually assume that as firms grow, they build the organizational capital to become better at R&D. That's a standard assumption. But what we're arguing is that that benefit of expertise is particular to the kind of technology that you've invested in the past, right? Just because you've been drilling up oil for many years, right? It doesn't make you better at coming up with better solar panels or something, right? But it does make you better at developing new oil drills because that's your core business. Okay, so there's evidence of that at the firm level. So firms tend to specialize either in clean or dirty innovation, and there's also empirical evidence of this at the worker level. So we know from individual researchers that they tend to either innovate in clean or in dirty. They don't tend to switch, even if there are financial incentives to do so. Right? So by now, every one of us probably wants to be a sociologist or something, but we're so vested in being economists that we can't switch. Right? So there's path dependence in the kind of research that we do, and the same applies for innovation. We also have entry works very similar to how we have innovation by incumbents. Obviously, entrants don't produce anything yet, so for them, this R&D production function, so the rate at which they get patents, doesn't depend on how many products they already produce. Right, because they don't produce anything yet. So entrants in this model are going to be very, very nimble, right? They don't have this track record of either dirty or green R&D. So when there's a change in the incentives to invest in green or dirty, the entrants are going to jump ship first, right? So entry is going to be an important driver of a transition. So then to the financial side of the model, we have a very simple way of modeling finance, in the sense that we're just going to assume that for young firms, it's more expensive to finance their R&D. So we have a micro foundation for this in the model. The micro foundation is monitoring costs. The idea is that for a young firm, it's harder to get financing because the bank has to invest more into managing you. But you can just think of this as a parameter if you want. We're just going to say that during a financial crisis, it's the young firms that face a big increase in their cost of credit, or more broadly, they're just not able to get the credit to make the investment that they make, right? So it is microfunded, but the way that I think of this is just as a parameter. We see in the data that it's hard for young firms to get credit. We're just going to impose that, right? If you want to have a 10-page finance model that delivers that, you could write that. So optimization in the model. So we have static optimization. So every period firms choose their optimal price, and we have dynamic optimization, which is for R&D. So this is the static optimization side of the model. We have firms that are the owners of the leading patent of a good. They have the highest quality patent. They're going to be producing the good in equilibrium, and they're going to limit price their closest competitor. So the price that the leading producers are able to charge depends on the difference in quality between them and their closest competitors, as well as any difference in marginal cost. That means that the markup, right, the ratio of prices to marginal cost that I'm able to charge, is going to depend both on the technology with which I produce, as well as the technology with which my closest competitor produces. Now, remember, whenever I innovate, right, whenever I get a patent, I improve the quality with which a product can be produced with some innovation step size. That's lambda. And the higher the innovation step size, the higher the markup. But other than that, the markup is going to depend on marginal cost. So if I'm a clean producer, my closest competitor produces with the polluting technology, the markup is going to be equal to lambda times the relative cost of producing. Vice versa, if I'm a dirty producer and my closest competitor is clean, the markup is going to be lambda divided by this P tilde, right? So the more expensive it is to produce with the polluting technology, the higher the markup is going to be of the clean firms, right? Sometimes there's a bit of confusion of this in policy debates. Sometimes people say, hey, we need to tax flying more because it's going to make the trains more affordable. That's not going to happen, right? If you tax flying more, if you raise P tilde, actually the train companies are going to jack up their price, right? It's actually going to make trains less affordable. Like Eurostar is not a charity, right? They're profit maximizing. And of course, if both firms produce with the same technology, then the markup is just given by the difference in the quality at which they produce. So that's the lambda. And we have dynamic optimization. So firms choose the arrival rate of patents, so how frequently they get the technology to produce a good that they didn't yet produce. Now, I'm not going to talk through the whole notation, but the key things is on the left-hand side of the equation on this slide, we have the arrival rate of patents. In the brackets here, we have this V, which is the value of getting a patent, either clean or dirty. In the denominator, you have some costs. But importantly, at the outer end of the equation, we have the number of patents that the number of products that firm I already produces in a particular technology. So when the economy is in transition, by which we mean if there's a gradual increase in the value of being a clean producer instead of a dirty producer, that's going to increase the incentive for firms to innovate in the clean technology. But it doesn't necessarily mean that innovation in clean technologies is going to increase very fast because firms don't have a track record yet, right? So the N in this equation for clean technology is low. So at the start of the transition, even if green innovation is very profitable, it's just very hard for firms to actually engage in clean innovation. So let's think through what happens over the whole transition and when there's a financial shock. So the transition is given by an increase in V because there's an increase in the markups of clean producers. Initially, the firms that are going to have a track record of clean innovation is going to be the young firms because the entrants jump ship right away. Entrants are young, right? So the first couple of years that they're in the market, they're younger than the incumbents. So the first stages of the transition, innovation capacity in green technology is going to concentrate among young firms. That means that when there's a financial crisis, which is an increase in the financing cost of R&D for the younger firms, right, that endogenously is going to harm green innovation more than dirty innovation because it's the young firms in which this innovation capacity resides. Now, it's a general equilibrium model, so we solve everything properly. There's no way for me to click the buttons. If you wanted to see any of the appendix slides, you're out of luck. But the paper is online, so you can read it. You can read it there. Quickly on the empirics, so we provide empirical evidence of the mechanism that I outlined using differential exposure to the global financial crisis among German firms. Now we're going to look at the firm level at the effect of exposure to the crisis on green patents and dirty patents separately. We measure exposure to the global financial crisis from firm banklings, so for a set of German firms. It's a small sample, just 600 firms. We observe the banks from which they borrow. Now in Germany, there was one bank that collapsed, or that really restricted its corporate lending in the aftermath of the global financial crisis, and that's Commerzbank. So they cut their corporate loan portfolio by 40% between 2009 and 2013, and that was because they sold their toxic American mortgage-backed securities too late. Right? So that's why Commerzbank contracted its corporate loan portfolio more than other firms. And as a result, firms that before the crisis relied on loans from Commerzbank were more exposed to tight credit during the crisis. So what we look at is if you compare Commerzbank exposed firms and other firms, how does their patenting evolve around the global financial crisis? So we estimate a PPML regression. We can talk about the details later. The key thing is these graphs. On the left-hand side, I'm plotting the effect of being exposed to Commerzbank on green patenting, and on the right-hand side on non-green patenting. On the left-hand side, you see that Commerzbank, which reduced its lending supply between 2009 and 2013, with a lag, firms cut their green patenting. And so this is the effect of being primarily linked to Commerzbank before the crisis. Now, the effect here is huge. So to give you the vertical axis, that's the log change Okay, so 2, so that means that we're way outside of the range where logs and percentages are about the same, right? So this comes to about a 60% decline in green patenting. Obviously, many firms just have 1 or 2 patents, right? So elasticities, you would expect them to be quite large. On the right-hand side, you'll see that there's no significant effect on non-green patenting. Okay? Now, why is that? That's because of the identity of green innovators. So we can do a triple difference regression where we say, look, what's the effect of being tied to Commerzbank on young versus old firms? And what we find is that the only effect of exposure to this bad German bank on green innovation is on the younger firms. Now I say younger, not young, because this is just below median age, right? So the average age of a young firm here is something like 15 years, right? So these are not startups. We have 600 firms, right? So this is exactly why we're doing this for France. We can't go to 10 age categories. And in France, we do see the younger the firms get, the more exposure to a financial crisis is going to harm your green innovation, exactly like you would expect if monitoring costs are making it hard for young firms to get these loans. And of course, we need to show that young firms are responsible for a large share of green innovation. That was true before the global financial crisis, but not today. So this graph on the vertical axis plots the fraction of all green patents for which young firms are responsible. So before the global financial crisis, firms that are young at the onset of the crisis, and again, the average age of a young firm is 14 years, right? So they're not startups. They're responsible for 70% of all green patents. If you look at non-green patents, they're only responsible for 20% of them. So exactly in line with the model, you see that these young firms self-select into green innovation. But after the financial crisis, right, they cut their green innovation, and so they become responsible for a smaller share. And so the first time that I presented this paper, someone told me, look, Maarten, the big green innovators are companies like ExxonMobil. So what are you on about with this green innovation? And then my response is, well, 1, that's true after the global financial crisis, not before. And 2, why do you think that is? Does ExxonMobil have a comparative advantage in green innovation? Or does ExxonMobil have the money? Right? We argue it's the latter. Okay, so what we see is that tight credit is responsible for, it has a negative effect on green innovation that's driven by younger firms, and young firms are important for green innovation. That's what the model predicts. Now, before I go to the final bit of the presentation and discuss quantification, I am aware that we are at a central bank here. So I've got a monetary policy plot just for those who are interested. So the mechanism that we outline is not specific to the global financial crisis. A tightening of financial constraints should harm green innovation more than non-green innovation. So if central banks raise interest rates, that should affect green innovation more than non-green innovation. And that's exactly what we find. So this is a plot for the Eurozone. Is the impulse response of non-green innovation, that's the blue line, and green innovation is the red line, after a shock to monetary policy. And what you see is that there's only a significant negative effect on the green innovation as our model would predict. Now, the empiricist in the room, they might say, well, these confidence bands overlap. We can also look at the share of all patents that is green, right, as the outcome variable. And that share significantly falls, right? So a tightening of monetary policy harms green innovation more than non-green innovation. Okay, so quantitative analysis, we quantified a model to match pre-1995 moments. We're going to start a transition then because it coincides with the Kyoto Protocol. That's the end of 1997. That's when we start the transition. We're going to match the initial rise of green patenting, and then we put in a financial shock into the model that happens 10 years after the start of the transition. So 10 years after Kyoto, like we saw in the data, and then we see how much of a negative effect does this financial shock have on green innovation, and so how much can our model explain of what we see in the data. So this graph shows 2 lines. The black line is the transition of green patenting in a world where there's not a financial crisis. The blue line is the one with a financial crisis. Okay, so if you look at these lines, there is so we put in a 2-year sharp financial crisis. There's a negative effect. You might think, hey, look, Maarten, is this difference really so large? Well, we're looking over a 40-year horizon here, right? So if you zoom in, this financial shock actually has a very big effect on the speed of transition. In particular, if you compare the rate of increase of green patenting in the old path, that's the black line, versus the new path, so the path with a financial crisis, the blue line, there's actually a 47% reduction in the speed of transition. And in the data, we see that green innovation flatlines, right? So it's 100%. So we explain 47% of that slowdown. So I would say that's quantitatively actually very large. Okay. So the final point I want to make, this is the same graph, but it's just in terms of deviation from trends, right? So I'm basically plotting this and I'm detrending it. And so what you see is that the green transition, the fraction of all patenting that's green, actually falls behind trend by 10%. If the economy had been in steady state during the financial crisis, that's the black line here, there would not have been a bigger effect on green innovation than on dirty innovation. Because in the steady state, a green innovator is going to be equally old than a non-green innovator. But because the economy is on transition, young firms are self-selecting into green innovation, and therefore you get this negative effect of the financial crisis on green innovation. So I'll end it there. We find that green patenting slows during the global financial crisis. We say that this is not something that is particular to green technology, but it's because young firms on a transition self-select into green innovation, and young firms are the ones that are harmed by financial shocks. Thank you.
Thank you, Martin. Richard, you have the floor.
Okay, so thank you for giving me the opportunity to discuss the paper. Let me immediately jump to the summary to refresh the minds a little bit. So the very basic idea is there's nothing special about green innovation and financial markets in any way, right? But younger firms have tighter finances. And as the economy transitions to a green economy, the green firms will be young and the incumbents will be producing dirty stuff. And so it slows the technology transition if during such a technology transition you have a financial crisis or any other financial tightening. So the paper consists of a microeconometric analysis of a credit shock. Basically, I would say a shift share instrument with Commerzbank exposure. And we can see there that this actually happens, as the general idea would predict. So their green patents decline more than non-green patents. And then there's the quantified endogenous small growth model, where financial markets experience a shock and it shifts the composition of the economy, right? And then explains roughly 60%, I read somewhere, but it seems to be wrong, of the decline in green patenting after 2008. So I have a couple of comments both on the empirics and the model, so that's how I'll split it. So here, this was also the first graph that you showed today. And when I just look at that from my eyeballs, I'm not super sure that this is a significant difference, right? So it's definitely significantly different from zero, but is the green line really different from the non-green line? I think that's very hard to say here. But if you change the interaction terms, you could actually test that, right? Of course. Also, the empirics are a little bit different here from the model, right? In the sense that in the model, we would actually expect a zero coefficient. So the green and the non-green patents should, if I understand it correctly, behave in the same way, especially here in this regression where we have an interaction with age. And so I think the main column here is actually the column 6. That's the one that tests the model the closest, whereas the one where you have the green and non-green, that tests actually a difference of behavior that in the model doesn't exist, if I understand it correctly. So I found that, I mean, it's nice to have these extra things reported in a way, but I thought that there was a slight disconnect between the empirics and the model in that way. Yeah, so why not mainly test or make the focus of the empirical section more on Commerzbank interacted with young and less on Commerzbank interacted with young interacted with new technology. if we want to have this this triple interaction, I thought, well, when the standard errors are so large, actually the model doesn't say anything specifically about green technology, right? So we could use other technologies as well to increase the sample sizes and get the standard errors a little bit more under control, right? Because the problem is not that the two firms groups behave in the same way. It's more that the error bands are so high. So I wrote down a couple of other technologies that entered during this time period that is in the empirical exercise. So there's the mRNA injection, there's CRISPR, there's the electric car. So there would be other possibilities as well that I think in some cases at least would probably be easily identifiable in patent data as well. And yeah, using them all together will give you more statistical power. The last point I wanted to raise that, I think is a little bit, so we can talk about the problems of patenting data, of course, all day, but still, I think it would be important to note that financing tightness also may have a direct effect on what I decide to patent and what not, right? So if I'm under tight financial constraints and I really want to lend money, I might be under pressure to patent every little thing to show my investors, my potential investors, oh, look here, we have all the patents. So especially in startups, I think you see such dynamics quite a bit, that investors look at the patents to decide whether to invest or not. My main comment on the model is, why is there no capital? So I know, of course, that for tractability reasons in endogenous growth models, it's always very nasty to have capital there. But I think it might play a huge role, right? Because a part of the green transition is also a huge infrastructure investments, also a lot of just tangible capital as part of the production process as well. And this direct effect might actually be quite important compared to the dynamic endogenous technology effect that you find, right? So because the technology effect only lasts for like 15 to 20 years. And that's, for example, a shorter time than the expected lifespan of a wind turbine. So the capital effect might be quite large, and it might actually strengthen the result insofar as if you have this long-lasting capital compared to the endogenous growth dynamics that are going on. If you have worse technology in 5 years after the shock, then you will suffer the results from that for the next 20 years, right? Because this low-quality wind turbine is now installed, and it will produce energy or less energy than it could have. Yeah, and then another thing that I thought is, of course, it's very conservative to have the shock in the model as you calibrate it currently, right? So you have a very sharp dip and then it goes back to normal again. But when I look into your data, that's not actually what happens, right? So the total debt stays depressed for many years. And why not use that shock, right? And if you don't want to use that shock because it's sort of confounded by all sorts of other things, I would think that something like VC volume or something like this that's more closely about credit to young firms would actually be the better comparison. And then I have some minor stuff that I'll just send to you. Thank you. Richard. Thank you, Richard. Thank you, thank you. Thanks, Richard. Does this one work?
No. You want to?
No. How it works?
It doesn't work. Now it works. Okay. All right. I'm told we don't have past Goran, so Marcelo, are you coming up for discussion the next paper? That'll be great. So Martin, do you want to take a first?
I can quickly respond. Yeah,
Quickly
it's great.
respond,
Thanks
and
so
then we'll
much,
go to
Richard,
Christian.
for the great comments. I'll go through the main ones. So, is a difference that we find between green and non-green, the micro effect, is it significant? Yes, it is. But it's significant if you look jointly over the post-crisis period. So we have a small sample, and we're looking at many different years. So every individual year, you cannot with certainty conclude that the effect on green is bigger than the effect on non-green. But if you look at the overall post window, it's significant. I think even at the 1% level. So we're not concerned about that. Are the model and data consistent? I think the answer is yes. Right. So in the data, we find that there is indeed a small negative effect on non-green innovation as well. But that's actually something that the model predicts too. And the reason is that young firms just cut everything. Right. So young firms are not doing much of the dirty innovation. They cut everything, and so dirty innovation falls a bit. But just the overall effect is not that large. One thing in the data that is a little bit different from the model is that we do find that even for younger firms, they cut green innovation even more than the dirty innovation. So there might be something that's still different about green and non-green. We consider it more of a so in our paper, we show that even if there's no intrinsic difference between the ability of firms to finance green innovation and non-green, you're going to get that green innovation falls after a financial crisis. If there are reasons why it's harder to finance green innovation than dirty innovation, that is just going to compound the effect that we describe, right? So we really consider it a feature of our paper that there's no intrinsic difference and not a bug. But there are examples of why it might be harder to finance green innovation, and actually Guido has done some work on this. I'll just say one thing about the model. So do we find a small effect? Look, we explained 47% of this really big slowdown in green innovation. I think that's very large, but it's up to you. We very deliberately never target 100% decline, and the reason for that is that during the global financial crisis there was also a collapse of oil prices, which probably negatively affected the incentives for firms to invest in green innovation too. So we just put a short, sharp financial crisis into the model and then just say, what does the model predict for the path of green innovation? That's 47% of the slowdown that we saw. If there are other reasons that additionally changed during the global financial crisis that might cause a slowdown in green innovation, that can be the other 53%, right? So it's very deliberate that we never try to explain 100%. But for me, this 47% decline in green innovation is meaningful, right? Is big. 47% of the speed of transition. Sorry.
Thank you, Martin. Let's take some questions. Let's start over here with Ryan, and then we'll go with Massimo. And with, Eleonora.
I like the paper. There's sort of two ingredients here. One is that small firms have trouble getting finance, and the second ingredient is small firms are more likely to innovate green. Okay, right? Those are essentially the two things. And then you show that in the financial crisis, that's what the financial crisis did. I mean, cut off funding for small firms, so there was less green innovation. So I like all that. What I take issue with is essentially your last picture, and I think it's a little bit a sideshow, but where you in some sense suggest that monetary policy has an impact on green innovation. If so, because if it raises interest rates, small firms are going to be more bank dependent, have more problems getting funding, and then innovate less. But you just showed in the picture before that it's no longer as much small firms that innovate green, right? So I'm not so sure whether we should really go to the ECB and tell them, look, your monetary policy has this sort of negative externality that you probably don't consider at the moment. Do you really want to do that, or should you take that into consideration? If now it's the case that after the financial crisis, large firms are the ones that innovate, then that last picture, I mean, the rest of the page is fine, but that last picture doesn't work, right?
I disagree.
Let's take some questions. Let's
We're gonna have
round them up,
fireworks, but
and then we'll so Massimo, Eleonora, and then Gianmarco.
Sorry.
Eric.
I enjoyed a lot the presentation. I have two questions. One relates to the model. Maybe I missed something. In that case, I apologize. But since it's the story of financial constraints, I wonder, I didn't see in the model financial constraints binding, occasionally binding. So if there is some sort of endogenous mechanism that you can exploit directly in the model that support the. And the second question is related to whether there is evidence, because in that case, I would expect larger companies to acquire or to merge with smaller innovators in order to not have this financial constraint anymore. So that basically there will be incentives for dirty producers, larger, older dirty producers to get a unit of small, young green producer and circumvent the problem of the financial constraint. So whether if there is some merger and acquisition story behind the scene in the data.
Eleonora?
And the question is about the empirical part, because you base your analysis, if I'm not wrong, on 600 German firms, okay, several long time. So I think that you should provide more information about the representativeness of your sample in terms of firm age and size, which typically are highly related, and also about sectoral distribution in order to reinforce your results.
Yeah. Gianmarco.
So mine is more of a clarifying question. So about the model, what is intrinsically green in the green technology and dirt in the other technology? Meaning, I mean, apart from the fact that we call oil this additional input, is the perceived quality by consumers something that we should think of as appreciation for green or less damage, if you want, less loss utility? Should we think about pollution on the production side that fits into utility? So this is just purely clarifying.
Eric.
Yeah, I'm just also given the model trying to figure out where the policy interventions come. So one big part of the externality that I guess is in your N is in the learning by doing, and anything new is going to be at a disadvantage. So there, the question is, financing is one part of it, but the other one's just expected future prices of the two goods. So some kind of future, some 10-year from now guarantee of a subsidy would open up the market. So it would open up scale and direct technology. The other one, in terms of the last picture, following up on Ryan, I mean, that's just Gertler-Gilchrist, that small firms get harmed more in financial, when there's small financial shocks or even large financial shocks. That's because of monitoring costs. And that can happen to any small firm for whatever reason. And the question is, well, where should the policy intervention be? Should that be in the central bank trying to differentiate? Or should that also be that other policymakers on the fiscal side say, hey, when shocks hit, we're going to get misallocation because the growth is going to be in the firms not based on their productivity, but based on their access to finance. We need to deal with that. So you can have a very generic, economic policy apart from the central bank, so they don't have to worry about this.
One more question, Laurent.
Okay, thank you. So first of all, thanks for your paper. I would like to downplay a bit this idea that innovation is financed by bank, especially in the European Union. There, I would like to mention the role of private equity and venture capital, which contribute a lot to the financing of innovation. Then I would have a question about, did you look at the role of VC finance during the financial crisis? And there I know that there has been a slump in VC finance. And then on the second point, which was mentioned by Rent about the monetary policy, I think what characterizes a state of financial crisis is an increase in risk aversion. And it's why risky activity are more affected, unevenly affected. This has nothing to do with the change in the monetary policy rate, which is the safe rate, the risk-free rate. So the analogy between a financial crisis and monetary policy is a bit difficult to make for me.
All right. All right. Martin, you have 3 minutes.
I'm going to go for it. Okay, so I'll start with the clarifying questions. Gianmarco's point, so we load the whole difference between green and non-green on the cost of production. You can, given that the cost of production and difference in quality are isomorphic in this model, you can think of consumer preferences for clean production instead of dirty production as being part of our P tilde. But we just collapse all of that into the P tilde. Now, the way that they're different then for utility is that dirty production comes with an externality, but it's only a function of the total share of goods that is produced with the polluting technology, right? So when I buy a polluting good, I don't internalize the fact that there's going to be more aggregate pollution, right? Because the effect of my individual purchase is zero, right? So we choose to load everything on production, but you don't necessarily have to. Banking, so we keep the banking side of the model very simple, and that's just because we have no new insights there. So, I mean, I presented this in front of Tony Whitted at Michigan a few weeks ago, and she loved this because she was saying everyone is writing clumsy banking models that have no new insights. So she loved that we're just transparent. We say, look, this is a parameter. You can microfound it in a sophisticated way if you want, but there's no additional insight. So I do it. I think M&A is a good point. I think in general, there's a question of what is the boundary of the firm, and we know that there's real financial frictions that apply to young small firms, and somehow these firms are not fully bought. If you want to ask me why, I would say that there is something deeply specific about the way that firms are organized that makes it hard to just have any purchase, to make any two firms in the economy compatible. But you're obviously right that in the extreme case where there's no friction to purchasing other firms, you just buy them, and there can never be such a thing as a size or an age-specific financial constraint. Right? But in the data, we see that they're there. So apparently these frictions are very real. Okay, then the question about is innovation financed by banks? I think it's a good point. So we focus on bank financing in the difference in difference regression because because this is not just capital markets. We know that some firms are exposed to the financial crisis because of the bank that they're in business with, and some firms are not. Obviously, for those firms, bank financing matters, and the fact that you observe firm bank links means that you can run a difference in difference regression, right? So just to get identification there. But when we quantify the model, what we're targeting is the total change in credit supply to the corporate sector. Right, so for a quantitative analysis, this is actually not a concern. But for a diff and diff, I need to have that second diff. I can't get that from, say, the stock market or overall bond rates, but I can get it from differences between banks. Eric's point, yeah, I'm thinking, do I want to go to the firework yet? Or oh, so representativeness of German firms. Yes, sorry, let me do that first. So you're exactly right. So to be included in the sample, you need to be present in 2006. We need to observe your firm bank links, and you need to have at least one patent, right? That's how we can include you. The observing firm bank links, that's where we lose representativeness. And it's really hard to make the case that this is a perfect reflection of German firms. For France, we could start with the universe of firms because we have the firm bank links through the Banque de France. So that's what we're currently doing, and there it can give you a much more compelling answer that this is actually a representative sample. So far, we find very similar results for France. The only difference is that in France, only 40% of pre-crisis green patents come from young firms because many green patents are in the nuclear sector in France. So there's a difference in the age composition there. But other than that, we find very similar results for France so far. Eric, policy implications. Okay, so the model, there's two market imperfections. So there are two policy instruments needed to fix it. The first one is that green production doesn't have the externality that dirty production has. How do you fix that? With a tax on dirty production, right? So that's friction one. But the second friction is this age-specific financial constraint. How do you address that with age-specific fiscal policy? That can come from a central bank, as in the way that the ECB has made collateral requirements different for different kinds of loans. That's one way to address that friction, but it can also come from the fiscal policymaker, right? But that would be enough, right? So the way you address the new friction that we posit is not by just subsidizing green innovation more, right? Because then you're helping the mature firms green innovation in their green innovation, and that might do too much. What you want to subsidize is all innovation, dirty or green, by the younger firms, or helping them financing in their financing of the innovation. Okay, so then monetary policy should are our results valid? Okay, so I think they are. And I think they're valid for two reasons. First, the plots that I showed you actually are based on data between 2000 and 2020, right? So they include years of where the share of the younger firms in green innovation is higher and when it is lower. Then the question is it the case that because of the financial crisis, right, we now no longer have to care so much about these young firms and their role in green innovation? I would interpret our results oppositely from how you interpret them, right? And that's because the financial crisis meant that these young firms didn't grow as large as they would have in the absence of a financial crisis. So because of the financial crisis, the capacity of the economy through path dependence to engage in green innovation is actually weaker than it would have been. We basically pushed the whole transition a couple of years forward. So if anything, compared to a baseline path where there wasn't a financial crisis, I think we need to do more to help these young firms and not less.
All right. Thank you. Thank you, everybody. Big round of applause. And let's switch seats. You're up. I will give you cues, not clues. Take it away whenever you're ready.
Perfect. So good afternoon, everyone. First of all, thank you for the invitation. It's always a pleasure to join the CompNet annual conference. The location was fantastic and the level of the presentation super high, which puts some responsibility on me to close the conference with some dignity, at least. So I hope I won't disappoint you, all of you that are still here. So this is work I've been doing at the OECD with my colleagues Elia Costa, Lila Demu, and Stefan Lemp. So the usual disclaimer applies. These are just our views and not the institutional view of the OECD. Well, Martin, with his great presentation already, introduced the topic quite well, and we have been talking of green growth since 2 days. So the motivation of our paper is quite straightforward. We know that many countries, many OECD countries have committed to reach net zero by the mid-century. And we also know from the estimates of several institutions that, well, massive investments are needed to achieve these objectives. And we also know that a large portion of this investment should come from firms, from the private sector. It's not only government that can fund the green transition. And why is this investment so important? Well, the main way through which we can reduce firm emission intensity, that is, we can reduce greenhouse gas emission without reducing our production, is by, let's say, investing in those technologies that reduce our pollution, the pollution of our production. But some recent reports from the EIA and the ACB are showing clearly that investment is so far way below what would be needed to achieve the net zero objectives. And so a natural question is, why is this the case? Well, first simple reason, the social benefit of green investment is much higher than the private returns that firms get. So a very simple incentive story. But beyond this, our question is there also a capacity story? So assuming that there is still an incentive, so a convenience for firms to invest in green, are financial and organizational factors relevant in holding back investment in low carbon technologies? And most importantly, how does this firm capacity interact with our main policy tool, which is environmental policy, and namely carbon pricing? Well, let me very quickly go through a bit of the theoretical background, though we discussed it quite extensively. I'll focus the presentation today, for the sake of time, mainly on firms' financial capacity, but I'll try to give some snapshot on our results about managerial capacity too. And why does firms' financial capacity matters for firms? Well, here we start a bit from a different point compared to Martin model. Basically, we say, yes, there are some barriers which are specific to green investments. No, we cannot treat these investments as all other investments. And among those, many of these investments, especially those in integrated technologies, which are precisely the technologies aimed at changing the production process at its root in order to make it less polluting, are more risky than standard investments. These investments are risky and banks have less knowledge of them. So there is a sort of asymmetric information that comes in here. Second, revolutionizing the production process of a firm involves large upfront investments. So once again, more difficult to get financing for something which is quite large. There are large sunk costs. And of course, in certain sectors, certain firms still treat these investments with some sort of low priority as they are not their main business. So just to give you a quick overview of the literature and how we differentiate from them. So most studies have been carried at the country level. So really aggregated data, namely the paper by Ralph D. Haas and Popov, who show that equity financing is better suited than bank financing to finance green investments, or with country-specific data. Here, the barrier is really getting data on green investments. There are a few studies coming out from colleagues at the European Investment Bank, Fotios Kalantzis, namely, or Ralph D. Haas, which used the World Bank Enterprise Survey. But this is about emerging economies, which tendentially are more financially constrained. So our question is, do financial constraints matter also for green investment in advanced economies, so in OECD economies? And to do so, we did quite an important data construction effort, merging several sources. So our first bit of information comes from Refinitiv, the environmental model of Refinitiv. So we cover large listed firms, for which we have a survey asking for these firms on whether they are undertaking any investments either for mitigation or adaptation purposes. These data are increasingly used also from IMF, but just to convince you, as a sanity check, they are not completely crazy. You can look in the graph here, the average share of firms making environmental investment in key sectors. And as you would expect, these investments are the highest in the energy sectors, in manufacturing, in mining, while they are quite negligible in services. Second element is firm financial information. And we gather it from Orbis, which we match to Refinitiv via ISIN codes. And we develop several measures of financing constraints. Okay, we know measuring financing constraints at the firm level is quite of a challenge. You can look at firms' leverage, but then you miss what happens in the flow. Firms may be highly indebted, but have high profits, so no real constraints there. And so beyond some very simple ratio, we employ some composite indicators which tend to aggregate several aspects of financing constraints. We have here Carlo, who developed this so-called SAFE indicator based on the ECB SAFE survey. And what we did, and not only because he was my master thesis supervisor, but just because the work was good, we extrapolated out of sample the coefficient, and we created an indicator, combining several financial constraints measures. We do not only use the SAFE index, but also more standard measures as the Kaplan-Zingales and so on. But I won't enter these details here. So, and then we match this firm level information to some macro variables, and I want to focus especially on the environmental policy stringency indicator from the OECD, which somehow measures the price of carbon, the price, how much does it cost to pollute? And so we can see how firms' capacity interacts with the incentives that is provided through public policies. In a nutshell, this cross-country analysis is based on almost 7,000 unique companies operating in a wide range of OECD countries over the 2004 to 2020 period. We exclude 2020 to check our results do not depend on COVID and so on. So results are quite robust to the choice of the sample period. But again, this is just large listed firms, and the question is quite broad. Green investment is quite broadly defined. But I mean, at the OECD, we need to work with cross-country level data. So that's the starting point. What we try to do in the second part of the paper is to try to dig a bit farther on this
And we exploit very nice data from the Portuguese Statistics Institute and Ministry for Education. So they have balance sheet data for the universe of Portuguese firms, and then a representative environmental survey, which really enters into the details of which type of investments are firm pursuing. And importantly, this does not cover only large firms, but also SMEs. And what's interesting to see in the rightmost graph is this difference between investment in integrated technologies and end-of-line equipment. As I mentioned before, integrated technologies investment are those aimed at changing the production process to make it more efficient from an environmental point of view. While end-of-line equipment are just some sort of ad hoc remedies, like cleaning, putting a filter that reduce how much pollution is dispersed, for instance, in a river and so on, but does not change the process at the root. Well, let me start with a cross-country analysis. We estimate a very, very simple equation to start with to check whether there's a correlation between firms' financial constraint status and their propensity to invest in green. We control for a bunch of firm level controls, size, age, profitability, and country by sector by year fixed effects, which means we control for any shock occurring at the country sector level. And in a nutshell, what the table shows is, yes, there's a negative relationship between financing constraints and green investment. If we interpret these results causally, which I'm not doing, the magnitude of the effect is quite moderate, I would say. So we have a 2.5 percentage point reduction in the likelihood that a firm carries out green investment. And as the average propensity to invest is something around 35% in our sample, well, it means 8% of the average propensity. So it's sensible, it's not as huge as the effect Martin showed us, but that was green technology. So we are talking of much more risky kind of investments. Well, these correlations are robust to a very rich set of consistency checks, which I won't go through. But well, now I imagine your first two questions. It's okay, Guido, we are here, we are not at the seaside. You are showing us two correlations, but first, endogeneity. Clearly, we have some reverse causality. No, firms investing more are expected to grow more and being less financially constrained. And second, you discovered hot water. Financial constraints hamper investment. So what about your point that green investment is more affected than other type of investments? So what I'll try to do next is to enrich a bit the estimation strategy and try to answer these two questions. First, let's go back once again to the global financial crisis, which is a quite nice shock to be used to in a cross-country setting to try to build a sort of diff in diff kind of specification. Basically, what we do is that we assume that some firms who are more affected by the crisis than others. And following a large literature on the topic, we assume that firms with a higher short-term to long-term debt ratio at the onset of the crisis are worse positioned to weather the shock because they are subject to rollover risk. No? They have to renew their debt in a turbulent time. And what you can see in the left graph here is mainly the proof that our parallel trend assumption hold. Okay, so we are comparing exposed and non-exposed firms before, during, and after the shock. And what you can see is that the pattern was quite similar before the shock, but more exposed firms really reduced their average propensity to invest during the global financial crisis. And we translate this into the econometrics, and you can see on the right-hand side the total effects split by period. And indeed, you can see that firms differently affected from the crisis are significantly hit just
in the global financial crisis period. Next, we try to further deal with this endogeneity. I mean, further, we just try a different path to handle this, to make our results more convincing. And we adopt an approach which is similar in spirit to a sort of Rajan and Zingales. What it means, once again, we identify a set of firms which is by itself more exposed to financing conditions, to aggregate financing conditions, and we assume that the investment of a single firm is not affecting aggregate financing conditions. And we take, so what we estimate here is a purely differential effect between exposed and non-exposed firms, once again, but this allows us to fully saturate the model, once again with country by sector by year fixed effects and firm fixed effects. So what are our proxy for macro financial conditions? Once again, Martin anticipated all we are doing. Once we have monetary policy, policy rates, both in terms of levels and in terms of change, as well as the average lending rate to firms in the country. And what you can see is that the propensity to invest in green is indeed lower for firms more exposed to changes in aggregate financing conditions when there is a tightening of those aggregate conditions. And finally, let me try to handle here the second question. So, okay, financing constraints hamper green investment, but what about the share of green investment? Admittedly, here we were not able to answer this question with our cross-country data because our green investment and total investment variable were not directly comparable. If we were taking the share, the results were holding. You should trust me, but I mean, as the measurement was so different, we wanted really to see, is this true? And here is where the Portugal case study comes at hands and also allows us to check the different effect of financing constraint on the share of green investment on integrated technologies and the share of green investment on end-of-line equipment. And what do we find is that indeed green investment reacts to financing constraints more than investment for in other technologies, but this effect is almost fully driven by investment in integrated technologies. And if you think about it, this perfectly makes sense because these are exactly those investments which were requiring large upfront fixed costs, higher risk. So are exactly those investments for which you can expect those differential to be there. And yes, here we come, let's say, probably to the core of the policy conclusion that we want to reach with this paper. So we have estimated this elasticity of financing, of green investment to financing constraints, and we're asking ourselves, how does it vary with environmental policy stringency, okay? So are they substitutes or complementary? And what we find quite interestingly is that when market-based environmental policies are quite high, so basically when the price of carbon is set to be very high, this relevance of firms' capacity almost disappears. So this would hint that once incentives change, firms tend to prioritize this kind of investment more, which is somehow logical, no? So we interpret these findings by saying that, yes, we find an effect on firms' capacity, but in the end, probably incentives matter even more than capacity constraints that firms may be facing. And as promised at the beginning, just a very quick snapshot on management. The empirical setting is very similar to the one we have seen before, but basically we are highlighting the results of our green management practice variables out of the control vector and just putting it out and see what's the sign of these variables? Clearly here endogeneity is even larger. You have a green management team if you plan to do green investment. No? So the positive correlation is not surprising at all. And how do we deal with it? We follow the Haas and co-author and just use a leave-out instrument. So basically we compute the average level of green managerial practices at the country level, excluding the sector in which the firm is located, and use it as a proxy for the firm, let's say, green managerial quality. But of course, this is quite rough and you know, still deserves some further work, even just because such aggregate instrument imposes us to reduce our rich fixed effect structure, putting in question the existence of further confounding factors. Just a small note on the right graph in this slide, which we believe is quite interesting, is the differential impact of different type of green-related stuff and how this varies for investment in integrated technologies and end-of-line equipment. Given their simplicity, what matters for end-of-line equipment is having really technical staff trained for this kind of installations, let's say. But when it comes to integrated technology, where you need a sort of long-term plan, then here is where the top management quality comes into play. And well, let me just conclude very quickly with another sort of sanity check. At least this is how we interpret it. There are quite some papers looking directly at financing constraints and emission intensity, but we wanted to be sure that, okay, in our sample, you are showing that firms' capacity matters for investment, but you know, does this translate, carry over to environmental outcomes, which is ultimately what we care? And this is exactly what the regression on the right shows, and the very simple descriptive statistics showing the average emission intensity for unconstrained and constrained firms now shows quite a gap, which widens strongly after the global financial crisis. So let me conclude very easily. I think the policy implications are quite straightforward. Green investment, yes, can be boosted by improving firm capacity. We had a lot of discussion yesterday on developing the capital market union, developing the equity markets in the EU. Of course, all this is very useful, but our results on environmental policy stringency pushes us to say that what matters the most is really that strong and credible policy signal are essential somehow to increase awareness and change firms' incentives to invest. So this may even be more important than upgrading firm capacity. So thank you very much.
Thank you, Guido. And we have Marcelo, who has gracefully agreed to stand in and present Bas Goren's discussion, I believe.
Yes.
Go for it. Good luck.
Yeah. No, so thank you very much for the paper, Guido. Very interesting work. So we had a last minute inconvenience with the original discussant. So I rely on his inputs, also from my colleague Leonardo, and my modest inputs for this presentation. So a bit of the summary of the paper, very interesting paper, Guido, good work. The paper in general study how financial constraints and the lack of green managerial practices affect firm green investment. And it's interesting that the paper interact these two factors with environmental policies. And here a good, let's say, heterogeneity analysis you do, disentangle the policies, the different aspects of the policies, also the type of green investments, and this final yellow graph where you have technical staff, green managerial staff in top positions, and so on. The paper, it's really interesting that try these different mechanisms throughout the paper. It's a cross-country firm level based correlational paper using different data sets, good work and put them together. The paper had two main identification strategies, the different diff used in the global financial crisis, and use instrumental variables. The general comment is that it's extremely policy relevant. You do a great job in the beginning of the paper putting together the literature and the relevant questions. We see a lot of work and evidence there. So there's so much, it's so interesting that I would even considering splitting some things. You didn't mention in the presentation, but there is in the box this natural disaster event study you do in Portugal. Very interesting to be only in the box. So I would definitely highlight this more in the paper, really interesting. And so going a bit more on the remarks we had. So the paper starts with this main specification where the authors are regressing green investment on capacity and firm characteristics and fixed effects. And capacity here takes the form of financial constraints and later as environmental management practice, training managers. And throughout the paper, you use also other variables for green investment, and you play around a bit with your left hand and right hand side, also doing interactions. Very interesting. In terms of the econometric specification, when we see the summary statistics in the appendix, I see a lot of zeros along the distribution of some variables, especially the dependent variable. So you have maybe a risk of a limited dependent variable. So possibly you could test other models that handle this better, TOBIT 1, 2, 3, and so on. You have the famous issues of selection in the financial constraint variables. Small things to work on. In the paper, you defend argument why you are using OLS, but you still use Logit and you put the IV. What I like a bit is a discussion of the estimations using Logit and IV. I know the Logit, you cannot interpret the coefficient, but the marginal effects, it would be good to have also a discussion how they differ from the OLS. I felt a bit of this missing in the paper. Also present the first stage results for your IVs. In terms of data, there is this, the survey data caveats, is this question about green investment actually reflecting the actual green investment of firms. And also you have a bit of unbalanced sample with a lot of firms from the US. And we see in the appendix when you exclude them, you lose a bit of power in the regression. So it's something to look at. A bit on the identification. So there are some threats for identification. First is selection. So firms that invest in green will also improve their green managerial practice. So this may upward bias their results. Ideally, of course, we wanted a random assignment of a green managerial practice to firms, but currently the proposed methodology don't get there, but rather the effect of among adopters. The second point here is the endogeneity and reverse causality. So you use your IV uses firm different debt composition, but also firm debt structure. It's endogenous to their business prospects, productivity. So the question is if the firm, different exposure to the global financial crisis is as good as random, right? But in general, there is a great new evidence, correlational evidence in the paper. I would stress this a bit more and also try to discuss some more potential mechanisms behind the results. a bit on the suggestions. I think the previous paper addressed this well. Was my first reaction also to add this component of younger firms. We know that they have less asset turnover, so they might be more exposed to green investment, as you call. So it would be nice to see the other layer of heterogeneity in the results. If there's something interesting in terms of industry and sector, at least in the appendix, and other ways to move forward also with the paper. So you explore a bit different policies and you disentangle these different policies. So you could also try to explore discontinuity in some more specific policies. Also, as an additional shock for the financial constraints or for the green transition, you can use the ETS expansion as a shock. And for the financial constraints, there's a paper that used target long-term refinance operations in Europe in 2014 as an extra shock. If you cannot see firm bank data, which I see as a limitation, of course. And finally, so as the paper in the beginning, when we read the paper, like there's so many questions, so interesting. And when we finish the paper, we still have more questions. So it's really doing a good job to captivate us and still think about it. And we tried here to put some questions for the audience, but also for you about the following of the paper. So you propose the policies in the paper, they require subsidies and tax advantage schemes. So how this should be financed, I think it was something discussed yesterday. You put forward in the paper that more investment in green technology is needed. Okay, but what is the optimal level of that? What are the frictions, inefficiencies we want to get rid of to increase that? Green investment is risky, but like how different is this from other risk investments is an interesting question to dig in. And finally, we have this, okay, we need to disinvest from brown sector. But what is the welfare impact of that? Like, are these sectors more labor intensive? Who are the winners and the losers? So those are some questions to move forward. But great job, thank you.
Thank you, Marcelo. Guido, do you want to take some first crack at answering, or shall we collect some questions? What do you want to do? Let's collect some questions, Alain.
Yeah, thank you. Now, just a question about missing variables, because investing in green is also depending on how profitable you consider this investment is, right? And that relates to two main parameters: the discount factor, the WACC, whether firms are myopic or not. And the second one is also your expectation about energy prices, especially electricity and so on. So then how will you consider those missing variables could affect your results?
Carlo? Carlo, we'll go to the next question. Brandon?
Massimiliano.
Okay,
it's okay.
Massimiliano. Sorry, I didn't see you.
So, thank you. I think I'm not fully understood your concluding statement about the fact that about the relation between the financing constraint and the carbon tax, because I mean, if there is a constraint, a financing constraint, tight financing constraint on green investment, and the same firms has to pay a carbon tax for the brown investment, the financing constraint, you see, greatly reduces the the capability of the firm to substitute green for brown investments. So the combination of the mix of the two can make you see, can be even even generate some perverse effects on firms' choice, in the sense that maybe firms could also have an incentive to increase brown investment to improve its cash flow, in a sense, and in anticipation of a higher carbon taxation. And there is some literature that showed that, the Hartzman and Schuer paper by these two economists of Yale. Thank you.
Thank you, Massimiliano. Carlo?
Yeah, no, the question is related to the channels through which you find this drop in green investment, because Martin's paper is clear. No, I mean, you have an hypothesis on young firms that are more, let's say, intensive in green innovation, which makes sense, and they're also more exposed to financial constraints, and the combination of the two things leads to this drop. While here you have large firms listed, which in principle should have access to financial constraints, and yet you find that the deterioration of macroeconomic conditions in terms of liquidity affects their investments, causally or not, I mean, but that has a correlation. So why is this the case? What channel do you have in mind? Why is this because of this issue of alternatives? I found very interesting the finding that when the stringency of environmental conditions increases, firms would have a lower, if I got it correctly, propensity to decrease this in green investments. So it seems like it's a matter of average returns on investment for those firms under conditions of liquidity constraints. So it's a different channel that the Martin complementary could be, but different. So what is exactly that you have in mind?
One more question. Did I? No. So, Guido, take it away.
Thank you. So let's go in chronological order. So thanks a lot, Marcelo, for a super nice discussion, almost too lenient. I mean, no, I'm joking. It's a very good discussion. I think you correctly identified somehow what are the strengths and weaknesses of the paper. It's evident that we cover too much ground somehow in this paper. This is partly our job at the OECD. This is why we are exactly trying to disentangle this work in several smaller pieces, one of which we just managed to make it in economics letters, the part of financing constraints, and so on. But indeed, altogether, it is quite confusionary, probably. And let me start from the last slide that I see here. I think all these are great questions. I mean, but our exercise is reduced form per se. So it's very difficult for us to say, how do we evaluate welfare effects? How we disinvest from brown sector? I mean, we can rely on theory to do so, but I would mean either we need a model, and we have seen quite nice models in these 2 days, but let's say this is a bit beyond the scope of the paper. And indeed, on subsidies and taxes, well, carbon tax does not need to be financed. No, it is a tax. And you mentioned explicitly subsidies. We don't exploit discontinuities, but we look how the relationship changes with changes in the subsidies component of the environmental policy indicator, and we do not find any significant evidence. We find evidence exclusively on the market-based component of this indicator, which leads me to Massimiliano and Carlos' points. Carlo, you summarized better than I did in the paper what was the channel we had in mind, and indeed it is a sort of alternative. We know that these large listed firms are just relatively constrained, so it's a matter of incentives. But even if you are a bit constrained, somehow it seems green investment is the one being discarded. And here is where how we interpret this result on environmental policy as substantially changing the incentives, then I fully agree. Super smart point on, I mean, it can be a burden. So as soon as we start to look at SMEs and so on, this can be a burden. And I guess that size-based policy may be warranted here. So I think we could reconcile a bit the two different points. And finally, let's go about discount factor, energy prices, and so on. Yes, they all do matter. It's true, we don't see the rate of return on green investment for the specific firms. What do we have is we control for any shock at the country sector level. So what we are doing is comparing two firms over time in the same, operating in the same country sector, okay? So potentially facing, I know there are quite some heterogeneities across firms, but they're all tendentially large. So assuming that among firms operating in the same country sectors, they were facing similar energy prices. And so we tend to think this is absorbed by our fixed effect structure. What we do further with energy prices is, we have energy prices at the country sector year level, and we use it as a further instrument for the market-based portion of environmental policies. And we see that once again, when faced with higher energy prices, basically firms are a bit further induced to invest in green because that they have to try to become more efficient in their production, given the push up in their costs. And well, I think I have covered almost all the questions. If any is missing,
thank you so much, Guido. It's time to wrap up. So thank you, Guido. Thank you, Martin, for a great overview. Thank you to our discussants. And we're in perfect time to invite our chairman, Filippo, up to close the session up and send us home. So, Filippo.
So, time to close. This is Alexander. I thought it was Sandro. Sandro. Okay, that was Sandro. First of all, thank you very much. I mean, the governor yesterday was really right. Malta is an excellent place, to talk about competitiveness. And of course, on our hand, we were right to choose Malta. So I think all of us were very inspired by this location. And I think we're discussing fully, being in the middle of the Mediterranean on, your competitiveness. So there was a tremendous amount of messages that we can. I can mention a few results from, competitiveness is multifaceted, or financial shocks tend to actually hamper, the green transition. Business dynamism is low, but has a cross-country dimension. That's why actually CompNet is there, right? New firms tend to be not so. So there is a difficulty on new firm to emerge. The incumbent are not so actually innovative. New are actually difficult to come out. And then I can mention another, hundreds of this. I mean, so enormous amount of messages that all of us will reflect during the next few, possibly, year. So this is a tremendous amount of information that we got. You, as an audience, I cannot believe it, so active, curious, inquisitive. I mean, difficult audience for any papers. And so that's a great thing. And also the networking during dinner, not only because we were drinking, but there were very active people. So that's an incredible crowd. So that's amazing. So thanks a lot for you, being with us, so active and participative. And of course, thanks a lot to the organizers, Rolf Steinech, Julie Sabila, Alex Noel Rapa, Massimo Giovannini, on the Maltese front. And if I may, modestly, at the CompNet side, Adnan, Elena, Retu, and Tanya is not here, but she was really helping her a lot. Thank you very much. So next appointment, don't forget, put in the agenda, is Team Pro 4 in September in Barcelona. You cannot apply anymore, but you can participate. You can apply instead for the next call for paper for the next year conference in Vilnius, so in September next year. And there will be another, lots of other events going up. So be sure that we'll be very active. Consult our website and, consult us anytime to idea, whatever, comments, anything. In the time being, so I wish you a very, very safe trip back or a nice, Spaziergang or promenade around Malta. Is worth the tour, of course. And well, I'll see you in the next occasion. It will be very possibly very soon, hope. Okay, thank you very much.